Why? Because you see, if we are confident enough in this subject, yes, obviously, concept based knowledge or preparation definitely 100% is required. I'm not disputing that, but ultimately what is required is the confidence in this subject, right? So if we are confident enough in this subject, we can definitely score above 80. We can definitely score above 80. However, if you are not confident, if we make silly mistakes at the end, it will be below 40 as well. So it makes or breaks the attempt. So please be a little careful, be a little extra vigilant while preparation for this subject. Okay, so whenever we start our preparation for math stands logical reasoning, the first thing that we get is fear, right? Correct. So we have to come out of it, right? We have to come out of it, and we have to be confident. We have to say that yes, I can score well in this subject as well. That is the main objective of this session. That couple of days that we have, that is our main objective, and that is what we strive for. At the end of the sessions, the couple of sessions that we have, each one of you will be confident enough of scoring 60 plus minimum. I'm talking about minimum marks, 60 plus, right? So why I'm saying this, it's not that I'm just claiming something. See, it's simple logic. It's not rocket science. This subject is divided into what? 3 different categories, right? Maths, stats, and logical reasoning, 40, 40, and 20, right? In statistics, yes, when compared to mathematics, statistics is reasonably easy, right? It's not so tricky questions can be asked in that. It's mainly based on some formulas which we have to apply and get the answers, and some theoretical questions also can be asked, right? So in that, out of 40 marks, for me 30 for sure we have to score minimum. We have to score minimum 30, and obviously how to do that we'll discuss today. We'll start with statistics itself, then logical reasoning. It's fairly common sense more than technicality, right? So out of 20 we have to aim at 20. Obviously there would be some questions where we might not get right, so I'm taking 15 marks out of it. 30 plus 15, 45. Now the last one, maths. How much ever tough it is, can't we score 20 out of 40? We can definitely score. There will be some easy concepts there. I'm asking you to ignore the difficult questions, so easy questions, so we can easily score 20 out of 40 there. 30 plus 15 plus 20 is 65, right? I was assuring 60, so we can easily score 65 here. Okay, for some reasons we are not achieving the target that we are getting, so we might end up with 60 also. That is still decent, right? So this is how we have to focus, and this is how we have to approach, right? So the approach is the main thing that we have to have the right approach. First point, as I already said, we have to be careful. We should not be silly. We should not make silly mistakes, right? So because yes, I said that we have to be confident. At times we might be overconfident in maths and stats, so we will read the question, but while working on it we will go wrong. In any of the step we'll go wrong, or we'll get the correct answer in shading. While shading the OMR we'll go wrong, right? That happens to everyone. So we have to be a little careful. We have to be very focused. Those 3 hours in the examination, we should not lose focus even to the core of 0.01%. We have to be 100% focused. That is first point that we have to keep in mind. Second one, mindset. As I already said, come out of the fear. It's normal as any other subject. So accounts, will you have that fear? No, right? You will not have that fear because you are confident enough. Same confidence have in this subject as well. So it's our mindset, it's our approach, right, that we have to change. Third one, yes, I'll be giving some timetable on how to go about in the next 6-7 days. Suggested to follow that timetable strictly. So it's not that we have to be rigid towards that. If you want to change a little bit, you can always change if it works well for you. However, based on what the analysis that I have done, this should be the best approach that we can have in the next 6-7 days. Okay, so strictly follow that. And what should be our approach? We have to change. In accounts, what we were doing, we were going completely in detail. When solving the answers, we were writing working notes, complete in detail, stepwise. But here, no, we have to be complete opposite. We should get answers in seconds, right? So no detailed workings. However, in certain cases, you may still go with detailed workings. In certain concepts where you're not too confident going too fast, you still go slow and get the answer, no worries. But in most of the cases, we have to be very quick. Preferably, get answers without using your pen, that is using calculators. Using calculators itself, get the answers. How to do it? Again, practice, right? In the next 7 days, we can do that as well, if you have not yet got hold of that particular practice. So detailed workings is not required. Calculator steps. So use the same calculator that you're using in the examination. Don't buy a new calculator on the examination day. If you want to buy a new calculator, buy it today itself, so that you will get used to it, so that it's not strange on the examination day. Okay, so use the same calculator now for practice that you will be using on the examination day. Preferably carry 2 calculators in the examination, so that if one gets a breakdown, you can use the other one. Second, next one, mathematics and statistics, 75 to 80% of it is formula. So what we have to do, write down all the formulae at one place of all maths and stats, all subjects. When we have to do this? Now, when we are reading in the next 6-7 days, when we are preparing in the next 6-7 days, write down everything at one place, so that it helps you the day before the examination. You have to just go through that particular page where you have written all the formulas. You will be getting all the formulas at once. You need not look into the material once again, right? So write down all the formula at one place. And now for the preparation, what we have to refer, what is the material that we have to refer? For concepts, only CAPS material. That too, the revision material is sufficient. Okay, statistics, we have already shared the revision material earlier. Go to the same material. Logical reasoning, today we have shared it. Mathematics also will be shared. Nothing to worry about. Okay, mathematics also will be shared. So for concepts, go with CAPS material itself. For problems, study material, not more than that. That too, in study material, don't solve all. Okay, you have no time to solve all the questions. If you have already solved and identified some technical questions, some tricky questions that you have to go through those questions. If you have not solved the study material problems, go through some of the sample questions in the study material. See, at the end of the day, if you're conceptually clear, any question under the sky you can solve. Even without solving the study material questions, if you go to the exam, you can still get the answers. But if you solve the study material questions, you will get hold of the pattern in which the questions will be, so that it will be easy in the examination to approach, right, to attack the question. So that is the reason why I'm asking you to solve some study material questions. Is that clear? Yes. And during this 7 days that we prepare, 6-7 days that we get for preparation, if you get stuck in any of the question, okay, in any of the question, if you get stuck, don't be there stagnant. Leave that question, go to the next question. Okay, don't waste time. Even if worst case that question comes in the exam, that is one question, leave that question, nothing to worry. Okay, because of that, if you're scratching your head for that question now, you will be losing 4 to 5 additional questions which you could have solved during that time, right? So for 1 mark, please don't lose 5 marks, right? So please don't worry about any of the questions which you're not getting. At this point in time, when you're preparing, say that question will not come in the examination, and move on to the next question. Is that clear? Now, most important point in this particular paper, negative marking, right? Negative marking, how to approach the negative marking. Again, that completely depends on your decision. Okay, whether to go with all the questions or going with only those questions which you are confident with. Okay, what I suggest is, which I believed and which I followed. If you are confident of 60 questions, if you're confident of 60 questions in the examination, that all those 60 questions are pakka, 100% correct. In that case, what I still suggest is go with the other 40, answer the other 40 questions also. Why I say this is, worst case scenario, even if those 40 questions goes wrong, what is the marks that you lose? 10 marks. 40 into 25% is 10 marks. So 60 minus 10, 50, you still get 50 marks. Whereas if you're not confident, with more than 50 questions, if you're confident with around, let's say 40, 45, 50 questions, in such cases, please don't take risk. Okay, please don't take risk. Only those questions which you are confident enough, answer those questions. However, if those questions where you are, let's say 50-50, etc., don't take risk in such cases. At the end of the day, those questions which you are not aware of, go with the gut feeling. If your gut feeling says, yes, this should be the answer, and you're confident about it, go with it. If your gut feeling says, I do not know the answer, leave that question. Okay, at the end of the day, that is what works in the examination. Clear with this? Any doubts in this before moving on to the timetable, etc. It's okay even if we spend 5 minutes extra here, because unless we get the approach right, there is no point in slogging with the concepts, problems, etc. Right? Clear with this, everyone?
Yes, sir.
Great. Okay, fine. So what we will do, how we should approach in the next 6-7 days? Obviously, we'll be starting with statistics in today's session. So your preparation also can start with statistics, right? So today you might get, after my session, you might get another 2 more hours for preparation, not more than that, right? So in that, what I suggest is complete the first chapter, statistical description of data. Simple chapter, theory, but go in detail, because each and every sentence there could be an MCQ question in that particular chapter. So go in detail and complete it. Simple chapter, first chapter, you'll get 5 marks from it. So 5 marks will be in your pocket. Tomorrow, yes, you have revision class, but before that you have ample time for preparation. You'll get 3/4 of the day, right? So in that time, target only the second chapter, which is measures of central tendency and dispersion. Go in detail with regard to that chapter. Measures of central tendency and dispersion. Okay, I'll write it down, no problem. Today is 30th May. 30th May, we go with statistical description of data. Statistical description. Tomorrow, 31st May, measures of central tendency and dispersion. Not only central tendency, measures of central tendency and dispersion. You have huge amount of time for preparation, and it is required, and it's worth. Why? Because 10 to 12 marks will be there from that chapter. So it's equal to 10% of the entire examination paper, right? So 10% of your syllabus is from this chapter. So it's worth spending time there. Then on 1st of June, we can go with another technical aspect, probability and theoretical distribution. Probability and theoretical distribution, connected chapters, but we have to spend time specifically in theoretical distribution, could be a little tricky. And if time permits, also you can go with index numbers, a simple discussion, index numbers. So this, all 3 chapters put together, 18 to 20 marks would be there. Then next day, 2nd June, we will be left with only 1 chapter in statistics. What is that?
Regression.
Correlation and regression. Correlation and regression. After that, I'll give you 2 to 3 hours of cushion. Okay, 2 to 3 hours of cushion. What we should do in those 2 to 3 hours? Sleep. No, Pradyumna, no, not sleeping. Okay, next, those 2 to 3 hours, whatever you have left in the previous days, if you couldn't complete in any of the topics there, complete those topics. If you have completed everything, what we have to do? Again, not to relax, solve additional problems in this. Okay, solve additional problems there. So correlation regression plus 2 to 3 hours cushion. Then we'll be left with another 4 hours in that day, where we can go with logical reasoning. The first 2 chapters, obviously. We need not rush in logical reasoning as well. The first and second chapter of logical reasoning, number series and direction test. Then on 3rd of June, Friday, 3rd of June, then next 2 chapters of logical reasoning, 3rd and 4th chapter, seating arrangements and blood relations. And again, I'll give you 1 hour of cushion, where if you have left something, you can complete it or solve additional problems there, so that you'll be more confident about it. Then you can start with mathematics on that day. Mathematics, start with some simple concepts, could be equation and inequalities, etc. Simple topics you can start with. But on 4th of June, most part of the day, you have to go through time value of money. Yes, there are various concepts to be discussed in time value of money, but it will come for 10 to 12 marks. So please go in detail, time value of money. 10 to 12 marks. Simple. It's simple, but many concepts to be discussed. Then, if time permits, we can also go through set functions. Simple discussion. Okay. Then 5th of June. 5th of June, the balance concepts in mathematics. What are the balance remaining? I think we have left with permutation, combination, and APGP. And the last one, calculus. Right? Permutation, combination, APGP, and calculus. So these are the topics that are remaining on that date. You can complete that. Now on 6th of June, we all know we have mock test. Right? 6th of June, we have mock test. But morning, we'll still get 2 to 3 hours of time. So that time, what we have to do, again, I'll give you that cushion. If you have not completed any of the topics, complete it. If not, revise. Revise what all you have discussed in the past 6 days. Revise. Go through the formulas that you have written at one place so that it acts as a revision so that you can attend the mock test confidently. You can attend the mock test confidently. So this is the timetable that we can have for the next 6-7 days. Fine. Yes. Okay. So we roughly we might get 75 hours. We might get 75 hours in the next 6-7 days. Out of that, 30 hours is for statistics, 10 hours is for logical reasoning, 35 hours is for mathematics. Roughly, that is what I have allocated. That is what is allocated. Clear? So this is what I had to discuss, a general discussion on how to prepare. So with this, can we start with the main topic? Anyone has any doubts in this?
Sir, 35 hours for maths.
Yes, 35.
Okay, sir.
Maths is. Right. Okay. So can we start with statistics?
Yes, sir.
Yes, sir.
Yes, sir.
Yes. The first chapter in statistics, statistical description of data. Again, very important, simple topic, but very important. Why? Because each and every line item there could be an examination question. That is the reason. So we will go with the first part itself. The origin of the word statistics could be from the 4 languages: Latin, Italian, German, and French. Status, statista, statistic, and statistic. We have to remember this. We have no option. There could be an MCQ question wherein which is the wrong origin of the word statistics. They'll still give Latin, Italian, German, and French, but they would play around in this, right? They would play around in this. So we have to remember this original words. Then the definition of statistics, there are 2 types of definition: statistics as a singular word, singular noun, and statistics as a plural noun. As a singular noun, what is statistics? Statistics is the process where we collect, classify, analyze, and present the data. For that, we can come to a conclusion. So that process is called statistics as a singular noun. Whereas as plural noun, what we would have collected, the entire data that we have collected would be considered as statistics. So as a singular noun, the process is called statistics. As a plural noun, the entire data that we have collected is called statistics. Right? We have lots of applications of statistics. Right? There is wide application, wide scope. However, there are limitations as well. What are the limitations? There should be more than one data for applying statistical principles. So statistics deal with aggregates. Statistics deal with aggregate, and it is concerned with quantitative data. Can we have statistical analysis with regard to qualitative data? Not possible, right? Not possible. So we have to have quantitative data. If we have qualitative data, what we have to do?
Convert to qualitative.
Convert it into quantitative. Yes, convert it into quantitative. And we all have discussed regression analysis. What do we do in regression? Based on a defined relationship between 2 variables, and given value of one variable, we estimate the value of another variable. Right? That is what we do in regression. Now, this estimation of the value of the other variable, the projection that we do, is based on what? Based on some defined relationship, based on some specific condition. So if we do not have any defined relationship, if we do not have any specific condition, projection is not possible. Estimation is not possible. So future projections under a specific condition, and whatever conclusions that we get, It's built on a random sampling. It's not that we get complete information at all times. We go with sampling. So whatever conclusions we derive, it's based on such sampling. So there will be sampling risk. There will be sampling risk. So that is the limitations of statistics. Going with what is statistics, it's deal with data. So we have to discuss about data. We have no option. Data, we can divide it into two: quantitative, qualitative. What is quantitative data called?
Attributes.
Quantitative.
Variables.
Variables.
Quantitative is variable, qualitative is
Attributes.
attributes. Yes. And variables are further divided into
Discrete variable and continuous variable.
yes, discrete variable and continuous variable. Discrete variable such variable will have only countable values in that given range, whereas continuous variable will assume all values in that given range. Right? Example, number of petals in a flower. So they are countable: 1, 2, 3, 4, 5, 6, 7, 8. It's not that we'll have 2.5 petals, 1.35 petals in a flower. No, unless we break down half petal. Right? Continuous variable will have all values in the given range. Best example is height. So we can have 140.33, 145.88, any value, any given value in that given range. So that is continuous variable. Qualitative characteristics, we all know attributes. So the qualities, characteristics, the nationality, color, behavior, etc., all comes under qualitative characteristics. This is one part of the bifurcation of data, quantitative and qualitative. There is one more part of bifurcation of data, which is primary data and secondary data. This is based on what? Source. Very good. This is based on source. So based on source, we have primary and secondary. Primary means the person who wants the data, he himself collects it. Whereas secondary, data is already collected. Now we rely upon that data for our statistical analysis, right? That is the difference between primary data and secondary data. Primary data, we are more focused on primary data. Why? Because we are collecting it afresh. So there are different modes of collection of primary data. First one is interview method. Interview method, as the name says, we'll ask questions and get the answer, get the requisite information. However, it can be done in 3 different types: personal interview, indirect interview, telephonic interview. Personal interview, the person who is doing the interview, he himself goes and interviews the persons from whom he wants the answer. So he'll get the information from the victims themselves, from the then and there itself. So best example is in case of natural calamity, floods, etc. Go to that particular village or area, ask those persons who got affected by the flood and get the information. That is direct interview, personal interview method. Whereas in case of indirect interview, yes, the person who wants the information itself will interview, but he cannot interview the victims. So in such cases, what he'll do, he'll go and he'll visit that place, but he'll collect the information from those persons who were incidental to that incident, who are not directly involved in that incident, but who are incidental to that incident. Best example, in case of an accident where there is loss of lives, obviously we cannot go and interview the dead people. So what do? We interview the eyewitnesses there, right? We interview the eyewitnesses there. That is indirect interview. Last one, telephonic interview. So sit in an office, through telephone, get the information from all the people. So from the requisite people. So what are the advantages here? In case of personal interview, responses are better. Personal as well as indirect interview, responses are better because there is some physical touch involved. Therefore, there would be the better responses. Whereas in case of telephonic interview, the responses would be very bad. There would be non-response. The non-responses would be higher. Which is expensive, personal interview or telephonic interview?
Personal interview.
Personal interview is expensive because it involves huge manual efforts. Therefore, it's very expensive. And which is consistent?
Personal interview.
Obviously, personal interview or indirect. But these are consistent when compared to telephonic interview. But telephonic interview will have wide coverage, whereas personal and indirect we can only cover small area. Right? Number of non-responses is maximum in case of telephonic interview method. Yes, this is the first method of collection, which is interview method. Next one is mailed questionnaire. In mailed questionnaire, what do we do is we will prepare a set of questions, print those questions, send it through mail. It could be physical mail or electronic mail. So we send it through mail. The respondents, what is the responsibility? They have to get that questionnaire, fill up that questionnaire, send it back. Right? That is mailed questionnaire method. So it comprises of framing, well drafted and soundly sequenced questionnaire, covering all the important aspects of the problem under consideration, sending them to the respondents with prepaid stamp after providing all the necessary guidelines for filling up the questionnaire. Obviously, the required instructions should be given. Now, advantage here is we can cover wide area. We can get the information across the country, right? We can send the questionnaire anywhere we want. So we can cover large area, wide area. But disadvantage? Non-responses. The disadvantage is non-responses is maximum because responsibility is with the respondents. So obviously, when we give an option to them, they will not respond. So the non-responses would be maximum. Then next one is observation method. Under observation method, here we are not asking any questions to anyone. Rather we get the information by our observation itself. So we observe and collect the data. Data are collected by direct observation or using some instrument. That can also be done. So when we are getting the information with regard to height and weights of groups of students, we ask the students to stand before the scale or weighing scale or the height scale, and from that we, based on our observation, will record the heights and weights. That is observation method. What is the advantage here? Most reliable information, because we are not relying on anyone, including that person from whom we have to get the information. We are relying on ourselves. We are relying on our observation, right? Therefore, it's the most reliable method. However, time consuming, laborious, covers only a small area because lots of manual work is required. Last method of collection of primary data is questionnaire. Here, the difference between mailed questionnaire and questionnaire. Both cases, we prepare questionnaire. In mailed questionnaire, we'll send the questionnaire to the respondents. Whereas in questionnaire method, we'll appoint enumerators. We'll give them the questionnaire. We'll ask them to visit the respondents, collect the information, and come. Right. So best example is
Census enumeration.
Survey.
Census. Best example is census. Right, so wherein enumerators would be appointed and they'll go visit each and every household and get the information. So that is questionnaire method. So these are the 4 methods of collecting what? Primary data. Clear? Guys,
Yes,
getting
sir.
the flow, understanding?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, okay. Now, what are the sources of secondary data? From where we can get secondary data? It can be taken from anywhere, right? It could be from international sources till the local unpublished sources as well. International sources like WHO, ILO, IMF, the World Bank, etc., or government sources in the country, statistical abstract by CSO, Indian Agricultural Statistics, and some private institutes as well, ISI, ICR, NCERT, or unpublished sources of institutes, researchers, etc. So could be anywhere. It could be anything, any source of secondary data. So now we have collected the data. So with that data that we have collected, can we straight away start with our analysis? Obviously, no. This is the raw data that we have, right? So what we have to do, we have to check for the validity of the data that we have collected. How to do that? There is a process called scrutiny. The process of checking the validity of the data is called scrutiny, scrutinizing the data. So what do we do in the process of scrutinizing the data? We check whether the data collected are consistent or not. How to do that? Is there any specific method? No. Right? It's based on the intelligence, patience, and experience of the person who is validating, scrutinizing the data. So there could be some cross checks. In case of census, we can have a cross check wherein in the first page, we'll have the number of people in that house. Right, adults, children, etc. So if in that particular response, if they have responded that there are 2 children in that particular house, subsequently we'll record the details of those people. So there we should have responses of 2 children, details of 2 children. So if we have only one child's data, then obviously it's not consistent. First page says 2 children, subsequent details has only 1 child's information. So it's not consistent. So this is how we can cross check. Similarly, there could be various other means of cross checking other information as well. So this is how we can cross check the information, the data that has been collected. Similarly, there could be some errors that would have crept in the data that we have collected while writing or copying the answers on part of the enumerator. The respondents would have given the correct information, but the enumerator, while recording, he would have recorded the wrong information. Possible, right? And so we can check for internal consistency. So in such cases, if there is any incomplete information or inconsistent information, we can ask the enumerator to recollect the information. So once this is done, once we have scrutinized, once we have satisfied about the validity of the data, of consistency of the data, then we will go ahead with the next process. So we have the raw data. What we have to do, we have to have that data in an organized manner. So how to have that in an organized manner? We have to present the data in the organized manner. Before presentation, we have to classify the data, right? So we have the marks scored by students of first PU, second PU, BCom, everything at one place. Now what we have to do, we have to classify based on their nature. So, right? So we have to classify the data. With regard to classification, we have different categories. Frequency group, we call it qualitative data, quantitative data. We have to be careful with regard to this. The qualitative data is also called as ordinal. Quantitative is also called as cardinal. Right? Quantitative or ordinal, quantitative and cardinal. We have already discussed. Qualitative is attribute, quantitative is variable. Whereas there are other methods as well, which is non-frequency group, chronological or temporal or time series, geographical or spatial series data. Now, what is chronological? Based on
Time.
So we would classify the data based on time. Similarly, if we classify the data based on
Geographical area.
Yeah, area. Based on area, we call it geographical or spatial series data. Right? So these are the different modes of classification of data. Different modes of classification of data. Once we have classified the data, we have to present it. Unless we present it, it's not possible for us to make further statistical analysis. So how do we present the data? We have 3 different methods. One is textual presentation, tabular presentation, and what is the third one?
Diagrammatic.
Very good. Yes, diagrammatic representation. Textual, tabular, and diagrammatic. Textual presentation, as the name says, write it in paragraphs. Article, right? Similar to an article in newspaper, write it in paragraphs. So that is textual presentation. So obviously, if we write it in paragraph, it is dull. It would be monotonous. Comparison becomes difficult. Why? Because so when we have to compare the data of 2021 and 2022, 2021 would be in a different paragraph when compared to 2022. So comparison becomes difficult, right? So these are the disadvantages. Having said that, what is the advantage? It is very simple. Textual presentation is very simple. Why? Because there is no rule. We can just write down all the information that we have in a paragraph. Whereas better method of presentation is tabular representation, that is presentation of data in form of a table, right? In the form of a table. Why? Why it is better? Because comparison becomes easier and further analysis also becomes easier. Systematic presentation of data with the help of statistical table. It is accurate, best mode of presentation. Why? It helps in comparison. So we have data of 2021-22 and 22-23 adjacent to each other so that we can compare them easily, right? So it helps us in comparison, and complicated data can also be represented. So 2020-21 and 2021-22, I have sales of 10 commodities. I have sales of 10 commodities. So if I have to bring it in, present it in textual format, then I have to have it in 10 different paragraphs, or could be 20 different paragraphs as well, because we have 2 years, 2 into 10, 20. But the entire information can be brought in one single table, right? So complicated information can be brought in one single table. Complicated data can also be represented, and for having diagrammatic representation, any diagrammatic representation, whether it's bar diagram, line diagram, or a pie chart, first we should have a tabular form data. Unless we have it in tabular form, it's difficult for us. We cannot proceed with diagrammatic representation. And statistical analysis is not possible without tabulation. We'll take simple statistical analysis, calculation of mean, median, mode, standard deviation, quartile deviation, mean deviation, etc. We want data in the form of a table, right? Unless we have it in table, statistical analysis not possible. So these are the advantages. These are the advantages of tabulation. Okay, fine. So having said that, so is it so simple that we'll just bring draw a table, rows and columns, bring the data at one place? No, there are some guidelines that we have to follow. There are some guidelines. So what are the guidelines? There is a format for a table that we have to look into. So every table will have a serial number. Every table will have a serial number and a title. It will have a serial number and a title, and we all know the format of the table, correct? What is the entire upper part of the table called?
Box head.
Very good, box head. And column heads are called?
Stubs. The caption.
Captions. Row head?
Stubs.
Stubs, correct. Row is called stubs. And the place where we get the data, we present the data, is called?
Body.
Body of the table. So if we have to, if it's not possible to bring everything in the title should always be crisp and short, right? So in such cases, what we can do, we can bring additional points below the title. We call it?
Footnote. Head notes.
Head note. Head note is above, right? So this is head note, and we can still bring some additional information like abbreviations, source of data, etc. Below the table, we call it?
Footnotes.
Footnote.
So these are the different parts of a table. Different parts of a table. Again, it's important. So serial number, title. Table as such will have 4 parts: caption, box head, stub, and body. And table to be well balanced in length and breadth. It's not that one of the column is too large, the other column is too small. No, it has to be well balanced in length and breadth. Arrangement of data should ensure comparison of data easily. And arrangement should be well balanced sequence, and presentation should be appealing. Footnotes at the bottom of the table. So these are the different parts: table number, title, caption, stubs, body of the table, head note. Why head note? Something that is not explained in the title, caption, stubs, etc. can be explained in the head note. They can ask this also in the MCQ questions, right? Saying why head note is used, or what will be used for explaining the certain aspects which cannot be explained in title, etc. So some such questions can also be asked. Footnotes, why? Source of data, exceptions in the data, abbreviations, etc. And table is divided into caption, box head, stub, and body. Caption is the upper part of the table, describing the columns and subcolumns, if any. Box head is the entire upper part of the table, which includes columns and subcolumn numbers, units of measurement, along with caption. Stub is the left part of the table, providing the description of the rows, and body is the main part which contains the data, figures, numerical figures. So this is how we bring in the data in tabular form. The last part of presentation of data is diagrammatic representation. So what is diagrammatic representation? Presentation in charts, diagrams, and pictures. What is the advantage here? Attractive, right? So it's appealing to everyone, and even both educated as well as uneducated section of the society can understand it, can be used by both. And any hidden trend in the data can be noticed easily. So when we have it in tabular form, we have to go for further analysis. But when we have it in a diagrammatic form, so if we have it in line diagram, let's say, so if we say that if we present the data like this, so we can come to a conclusion better, easily, quickly, right? So any hidden trend in the data can be easily noticed with the help of diagrammatic representation. However, what is the disadvantage? Since we draw it using graph, we go with scale, 1 centimeter is equal to 5 units, etc. It is less accurate when compared to tabulation. It is less accurate when compared to tabulation. That is the disadvantage of diagrammatic representation. Okay, there are different methods of types rather of diagrams. First one is line diagram. So this is used when data vary over time. So what do? We plot, we have x-axis and y-axis. So we plot the values of time and the corresponding values in the y-axis, and then join those points through straight line. It's not we are drawing a curve, it is through a straight line. We are joining all the points in the graph. With that, we get the line diagram. However, we can have different types of line diagrams. These 3 points are very important from examination point of view. So if there are lots of fluctuations, if there are wide range of fluctuations, what is the line chart that we use? Logarithmic or ratio line chart. So we convert the y values into log y and then plot it in the y-axis to get the line diagram, right? So when there is wide fluctuations, we go with logarithm or ratio chart. When we have 2 or more data, so if we have 2010 years and the production of wheat, etc., we go with simple line chart. But if we have production of wheat as well as production of rice, so we have 2 time series data. In such cases, we have to go with multiple axis chart. We have to go with multiple line chart. However, we can go with multiple line chart when we have 2 or more time series data with same units. If production of wheat and rice all are in tons, in such cases, we can go with multiple line chart. But if they are not in the same units, we have to go with multiple axis line chart. Then we will have multiple axes, X, Y, Z, so on. Okay, that is the difference. So normally we go with the normal line chart. However, if we have wide fluctuation, we go with, logarithmic or ratio line chart. However, if we have 2 or more than 2 or more time series, not more than 2 or more time series data, 2 arrow marks. If it is of the same unit,
multiple line charts.
If they are of different units, multiple axis line charts. Very good. We go with multiple axis line chart. Right. That is about line diagram. Then next one is bar diagram. So in case of bar diagram, again, we all know we record the information again in the graph with the help of rectangular bars, right? So such bars can be of 2 types, horizontal, vertical. Horizontal bar diagram is used for qualitative data and spatial geographical data. Vertical bar diagrams are used for quantitative time series. So horizontal is like this, vertical is like this. Vertical normally that we draw bar diagrams, right? So this is used for quantitative data and time series data, normal data that we use. Special types of data like qualitative and geographical data, we go with horizontal bar diagram. Again, can be asked in the exams. Having said that,
is there any specific reason why we should use horizontal?
No, see, at the end of the day, you can still go with vertical for qualitative and spatial data. There is no hard and fast rule as such, but this is a general practice that is followed. That's all.
Okay, thank you.
Yeah, and we go with normal bar diagrams. If we have more time series in the same given information, we can go with multiple bar diagrams or grouped bar diagrams, wherein for 2011, I will have production of wheat, production of rice, production of sugar, so on. Right? This is multiple or grouped bar diagrams. Or in one single bar diagram itself, I can denote production of wheat, production of rice, and production of sugar. This is called component or subdivided bar diagram. So if I have multiple bars in the same year, we call it grouped or multiple bar diagrams. If I have only one bar, but inside that, if I have multiple components, we call it component or subdivided bar diagram. The same component or subdivided bar diagram here in component or subdivided bar diagram, if let's say the total production is 2000 tons. So this is 2000 tons. We would divide it into 1200 tons, 800 tons, sorry, 600 tons and 200 tons. If the same thing is expressed in percentage, so 60%, 30% and 10%, we call it percentage bar diagram. If the bar diagram is represented in absolute terms in their respective units, we call it component or subdivided bar diagram. If the same bar diagram is represented in percentage, we call it percentage or divided bar diagram. Percentage or divided bar diagram. So these are the different types of bar diagrams, the different types of line charts. Those are important. The same thing, same information can be expressed in the terms of pie chart as well. So pie diagram or pie chart. What happens in case of a pie diagram or pie chart? We'll represent it in a circle. Okay, assume this to be a circle. What do? The data that we have, we convert it into what? Degrees. So how to convert it into degrees? What is the total degree?
360 degrees.
360 degrees in a circle. So we'll express everything in degrees so that the total of all the data, all the degrees that we have should be 360, and accordingly we will denote it in the pie chart. That will be pie diagram. So obviously drawing a pie chart or bar diagram or line chart obviously will not be asked in the examination. However, the theory part of bar diagram, line chart will be asked. In case of pie diagram, they can still ask what would be the corresponding degree that we will have for a particular data. So they can still ask us to calculate the degrees for the purpose of pie chart. Okay, so that is the different types of diagrams. So we are done with the presentation, textual, tabular, and diagrammatic presentation of data. Now in tabular presentation, we have something called frequency distribution. What is frequency distribution? What is frequency?
A number of times an observation
has been repeated. So if we have hundreds of observations where there are many repetition, instead of bringing all those observations one below the other, we can group them. Such groupings is called frequency distribution. Correct? So that representation of such groupings in a tabular form is called frequency distribution. Again, we can have two types of frequency distribution: discrete frequency distribution, continuous or grouped frequency distribution. So if I have single values, that is discrete. If I have range, we call it class intervals, right? 20 to 30, 0 to 10, 10 to 20, 20 to 30, so on. That is continuous frequency distribution. How to construct a frequency distribution? First, we should know what is the number of class intervals that we should have. So for that, we should know the total number of values in the observation. For that, we calculate the range. How to calculate the range?
Highest value minus lowest value.
Yeah, difference between the largest and the smallest observation, highest minus lowest. We get the range. Once we have the range, we should know what should be our size of the class interval. Size of each class interval, 5, 10, etc., depending upon the data. So once we have that, then we can calculate the number of class interval. Number of class interval is equal to range divided by size of the class interval. So with this, we get the number of class intervals. Once we have the number of class intervals, we know the lowest observation, right? Smallest observation. Start with that observation. We know the size of the class interval. We write down all the class intervals. Then start with the individual information given. Go with each number that is given. Each number, group it against the respective class interval using tally marks. So at the end, count all the tally marks. And write it in the subsequent column. We call it frequency. So total of the frequencies that we get should match with the total observation that we have. Total of the frequencies should match with the total observation. Right? So this is how we construct a frequency distribution. Now, once we have the frequency distribution done, there are lots of concepts there. We have something called class limit, class boundary, midpoint, right? What is class limit? For a class interval, class limit is the minimum and maximum. The minimum value of the class interval, we call it lower class limit. Maximum number, we call it upper class limit. So if minimum and maximum is called class limits, then what is class boundary? This is the actual class limit of a class interval. Now in a frequency distribution, in case of class intervals, we know we have mutually inclusive class intervals, mutually exclusive class intervals, right? Mutually exclusive class intervals are 0 to 10, 10 to 20, 20 to 30, correct? Why we call it mutually exclusive? Because the first value of the class interval is excluded. It's excluded here. So in case of mutually exclusive class interval, my class limits are not equal to class boundaries. Correct? True or false?
False.
False. Class limit is equal to class boundaries. Are we focusing? Guys, sleeping? Exhausted by writing the accounts exam?
No,
sir.
No, sir. Yes. So in case of mutually exclusive, see, my class limits and class boundaries cannot be different. It should be the same. Why? Because my upper class limit of the previous class and lower class limit of this class are the same. So there is nothing in between to have a different class boundary, right? So class limit and class boundaries are the same in case of mutually exclusive, whereas in case of mutually inclusive, it would be 0 to 9, 10 to 19, 20 to 29, so on. So in such cases, we have gap between the upper class limit of previous class interval, lower class limit of current class interval. Therefore, we will have different class boundary and class limits. So in such cases, how do we calculate the class boundary? So for the second class interval, we will calculate LCB and UCB. How to calculate LCB? Lower class limit plus or minus?
Plus.
Minus the difference, we call it B divided by 2. Correct? 10 minus 10, 9 minus 10 is 1. So 1 divided by 2. So 9.5 is the lower class boundary. Whereas upper class boundary would be upper class limit minus D by 2.
Plus D by 2.
Yeah, plus D by 2. Correct. So upper class limit is 19 plus D is 1. Difference is 1. 1 by 2. 19.5 is the upper class boundary. Clear? This is how we calculate lower class boundary and upper class boundary, right? Lower class boundary, upper class boundary, lower class limit and upper class limit. So if see those who are not getting this, those who have forgotten these concepts, don't panic. Okay, what we are doing is, it's not the final preparation that we are having. What this revision class is to ensure that we understand what are the concepts that are there in the syllabus so that we can prepare in the next 6-7 days. So don't panic, just go through the flow of the class and subsequently you can always catch up. Okay, nothing to worry. So for overlapping or mutually exclusive, upper class limit is excluded. So class boundaries coincide with the class limit. Whereas in case of non-mutually exclusive, we'll have different class limits and class boundaries. How to calculate, we have checked. So this is class limits and class boundary. Now for any class interval, we have something called midpoint. It's also called as mid value or class mark. Sometimes they'll ask in the question, calculate the class mark for this class interval. So at that point, we have to calculate the midpoint. So it's not that they'll always say midpoint. It can also be considered called as class mark. So it is simple, whether you are using class boundary or class limit, you will get the same midpoint. So lower class boundary, upper class boundary divided by 2, lower class limit plus upper class limit divided by 2, average of it. However, please don't interchange lower class boundary plus upper class limit. No, doesn't work. Right? If you are using class boundaries, it should be lower class boundary, upper class boundary. If you are using class limits, it will be lower class limit and upper class limit. Length of the class interval is difference between class boundaries, not class limit. Okay, 0 to 9. Even though class limits are 0 and 9, the size of the class interval is not 9, it is 10. Because class boundaries are minus 0.5 and 9.5, minus 0.5, 9.5 minus of minus 0.5 is 10. So length of the class interval is difference between class boundaries, not class limits. And then we have something called cumulative frequency. So we have class intervals and frequencies. If we add up all the frequencies on a class interval basis, we get cumulative frequency. So if we start from the beginning, we call it less than or more than?
Less than.
Less than cumulative frequency. If we start from the end, we call it more than cumulative frequency. Simple, right? So it's defined as the number of observation less than the value or less than or equal to the class boundary. Similarly, it could be more than the value or more than or equal to the class boundary. So we have frequencies, we have class interval and frequencies. 0 to 10 frequencies 5, 10 to 20 frequencies 12, 20 to 30 frequencies 18, so on. So in such cases, 30, 35. Okay. So if we calculate 12 divided by 10, this is frequency density. Frequency divided by the respective class size. we get frequency density. However, if we divide 12 divided by 35, we get
relative frequency.
yes, relative frequency. That is frequency divided by total frequency. We get relative frequency. If we do 12 divided by 35 into 100, we get percentage frequency. So if we do 12 divided by 10, the size of the class, we get frequency density. If we do 12 divided by 35, that frequency with the total frequency, we get relative frequency. 12 divided by 35 into 100 expressed in percentage, we get percentage frequency. Okay, we get percentage frequency. So this is about the concepts that are there in frequency distribution. The last part of the chapter, graphical representation of frequency distribution. So again, we have 4 types of representation in the graphical form: historical or area, frequency polygon, ogives, and frequency curve. Historical or area diagram is similar to bar diagram. The only difference here is, in case of bar diagram, we'll have discrete data, so we'll have gap between the bars. But here we use continuous data, therefore it would be adjacent to each other. Since it is adjacent to each other, in case of mutually exclusive, we have no problem. But in case of mutually inclusive, we will have gap between the class intervals. So what we have to do, we have to convert it into class boundaries. So in case of histogram, we have to convert the data into class boundaries. These also can be asked, okay, in the exams. So histogram, convert it to class boundaries. Then next one is frequency polygon, similar to what? Line diagram. It is similar to line diagram, wherein we draw the plots, we draw the plots, then we'll draw straight lines. So it's same as line diagram, but the only difference is we join the extremes to the x-axis, right? So the first one would be joined to 0. The next one would be the next value of x in the x-axis. So it will be in the form of a polygon. Therefore, we call it frequency polygon. Now here, what do we do? Where do we plot? Will we plot it in lower class limit or upper class limit of that class interval?
Class mark.
Yes, class mark, the midpoint. We go with the midpoint. We'll plot the data in the midpoint. So histogram, class boundaries, frequency polygon, midpoint. So that is how we have to remember. That is how we will remember. Then next one is ogives or cumulative frequency graph. As the name says, we will plot cumulative frequencies here, not the normal frequency, unlike histogram and frequency polygon. So we go with cumulative frequencies. It could be less than or more than cumulative frequency. So if we go with less than cumulative frequency, we call it less than type ogive. If we go with more than cumulative frequency, we call it more than type ogive. Right? Ogives, the important point is ogives can be used for what? For calculating quartiles. Median. Yeah, median and the other quartiles as well. Right? So if we draw both less than and more than type ogives, the intersection point will give you the median. But if you draw only the less than type ogive, and correspondingly, when we discuss about central measures of central tendency, we'll discuss how to calculate median using ogives. If we get the corresponding NP value and plot that NP value in that graph, then we get the respective quartiles Q1 and Q3. So our important point here is we can get quartiles using ogives. Okay, next. Last one is frequency curve. So the difference between frequency polygon and the frequency curve. Frequency polygon is a straight line. We'll draw straight lines. But frequency curve, we'll draw smooth hand curve. Frequency polygon, we go with frequencies as it is. Frequency curve, we convert frequencies into unity. What is unity?
One.
Right? We'll convert the entire frequency into 1 so that the total of the values that we plot in a frequency curve should be 1, and then plot that in the graph and then draw a smooth hand curve to get the frequency curve. Right? And alternatively, it can also be obtained by drawing a freehand curve through midpoints of the upper side of the rectangle forming the histogram. So we have histograms. Of each histogram, get the midpoint, draw free smooth hand curve through the midpoints of the histogram, we get frequency curve. we have 4 different types of frequency curve. Bell-shaped curve. So it would be something like this, wherein extremes, the values would be very minimum. At the center, the values would be maximum. The observations would be maximum. So this is normal curve in a normal distribution, right? Then U-shaped curve, it's reverse. At the extremes, the values are maximum, whereas at the center, the observations are minimum. Then J-shaped curve, at the start, the values would be minimum. At the end, the values would be maximum. So it goes on in the increasing order. Then mixed curve, combination of all, any of the above, combination of any of the above. These are the 4 different types of frequency curve that are there. Sorry, 4 different types of frequency curve that are there in the syllabus. So, okay, so these are the 4 different types of graphical representation: histogram, frequency polygon, ogives, and frequency curve. Histogram, we go with frequency, right? Histogram, we go with frequency, we go with class boundaries. Frequency polygon, we go with frequencies, we go with midpoint. And straight line, we'll draw the plots through straight line. And ogives, we go with cumulative frequency. Yeah, cumulative frequencies. And
Quartiles.
Yeah, we get quartiles, correct. We get quartiles. And frequency curve, we convert the frequency into unity. So we will not go with frequencies entirely. We convert it into unity 1 and then go with smooth freehand curve. Smooth freehand curve. So these are the differences between the 4 graphical methods, forms that we have, right? So these differences, simple differences, can be asked in the exams, right? So if we can write down this, it will be easy for us. Hope we have noted down. Are anyone still writing this?
Writing, sir.
Writing, no problem, write down. Done?
In the ogive, next to cumulative frequency, what is written?
Quartiles. We can get quartiles. I understand the handwriting that I have written is beautiful. Done?
Yes.
Yes. Okay. So this is the first chapter. So we'll quickly look into some questions. Okay, mock test, the recent mock test paper questions. Okay. Median of a distribution. Yeah. Yes, Pradeep.
Yes, sir. So in the question paper, will all maths questions be together, or
Yes.
will be mixed?
Yes. Generally it will be together. Okay. See, what happens is there will be different series of papers that would be made. I think 5 series, A, B, C, D, E. So it would be jumbled, obviously, but as far as what I know, mathematics first, logical reasoning next, statistics at the end. That is how the question paper would be set.
All 40 questions together.
Statistics all 40 together, maths all 40 together, logical reasoning all 20 together. That is how it would be.
Okay, sir. Thank you.
Yeah. Okay. Median of a distribution can be obtained from?
Okay.
Yes, ogives, correct. Cost of sugar in a month under the head raw material, labor, direct production, and others were 12, 20, 35, and 23 units respectively. What is the difference between central angles for the largest and smallest component of cost of sugar? What is the concept? Which is this concept? Pie diagram, correct. Pie diagram. So what we have to do, what are they asking? Difference between central angles for largest and smallest component. So obviously we cannot calculate it in detail now. Tell me the procedure. What we have to do here?
Convert it into
relative frequency.
It's a central angle. So we have to convert it into degrees, right? We have to convert it into degrees and find out the difference between largest and the smallest. Okay. So we have raw material, direct labor, and production and others, 12, 20, 35, and 23. So total we get 90. Okay, I have already solved, don't worry. 12 divided by 90 into 360, we get 48, 80, 35 into 4 is 140, 23 into 4, 92. So this is how we get 360 degrees. So which are the largest and smallest? Largest is 140, smallest is 48. 140 minus 48, 92. 92 is the answer. Right? So this is how we have to solve. Next, in a study relating to laborers of a jute mill in West Bengal, the following information was collected. 20% of total employees were female and 40% of them were married. 30 female workers were not members of trade union. Compared to this, out of 600 male workers, 500 were male members of trade union. 50% of male workers were married. Unmarried non-member male employees were 60, which formed 10% of the total male employees. Unmarried non-members of employees were 80. On the basis of this information, ratio of married male non-members to married female non-members. It looks too complicated, right? So when we look into this question itself, we'll skip the question for sure, right? What we have to do, we have to simplify this. What have they given us? They are saying 20% of the total employees were female. So out of total, we have male and female. Obviously, we know 20% is female. So 0.2x is female, 0.8x will be male. Right, first part. Then 30 female were not members of the trade union. We'll not look into it as of now. Compared to this, out of 600 male workers. So what is this? This is total male. So 600 is the total male workers. So 600 is 80%, means what is total? 750. Therefore, female would be 150. So we got the total bifurcation. Now in male, we have under male we have members of the trade union, non-members of the trade union. Female also we have members of the trade union, non-members of the trade union. Under members, they are saying some of them are married, some of them are unmarried. Under non-members also we have married, unmarried. Same in case of female as well, right? Members married, unmarried, non-members married, unmarried. First one, they say 30 female workers were not members of the trade union. So this is 30. Non-members are 30. So if non-members are 30, how many are members?
120.
120, because total is 150. Out of 150 is 30 is non-members, 120 should be members. Right? So we get this information. Then out of 600 male workers, 500 were members of the trade union. So if 500 are members, how many non-members?
100.
100, correct? 100. And 50% of the male workers were married. This straight away we cannot, because we do not know both cases of married details. So we'll come back to it later. Unmarried non-member male employees were 60. Unmarried non-member male. So this is 60. If this is 60, what should be the male married?
40.
40. Correct. Now they say 50% of the male workers were married. So what is the total? 600. What is the total married male workers?
300.
300. Out of 300 married male workers, 40 are non-members. So how many members who are married?
260.
260. So if 260 are married, what is the number of unmarried members?
240.
240.
240. So we got all information here. We have to get some information here. So for that, we have to go with the next part. Unmarried non-member employees were 80. So total unmarried non-member employees are 80. Out of that, unmarried non-member male employees are 60. So how many unmarried non-member female employees?
20.
20. So unmarried non-member female employees are 20. Which means, what is the number of married non-member female
10.
employees?
10.
10. Correct? This is 10. Now, we have to get this information. Total of married and unmarried female, bifurcation between members, female, married and unmarried. How to get that? Any information given? %40 of females are married. So 150 into 40 is how much?
60.
60. So out of 60, 10 are non-members. So this should be 50. 10 are non-members. So 50 should be members married. If 50 members are married, how many unmarried?
70.
70. So we get all the information. Now come
Yes,
to the question. What is required? Ratio of married male non-members. What is the number of married male non-members?
40.
40. Married male non-members, 40. To married female non-members. Married female non-members is
10.
10.
10. So 40 is to 10. What is the ratio?
4 is
4
to
is to 1.
4 is to 1. So 4 is to 1 is the answer. So all this we have to do in 1.5 minutes. Right? Such should be our speed. See, it's easy. We should not panic. Such kind of questions, what we have to do is we have to keep it at the end. Because at the beginning, if we do, we'll waste time, right? So we go with simple questions at the beginning so that we'll finish most of the questions. At the end, we'll come to lengthy questions.
excuse me, sir.
Yeah.
Sir, in that pie diagrams question, sir, instead of computing the angles for every value, can we just compute directly for the range?
Rajasthan, yes, we can do that. You'll get the same one.
We can do 35 minus 12. For that, we can compute the angle.
You can do that. You can do that.
Yes, sir.
Then for non-overlapping classes 0 to 19, 20 to 39, 40 to 59, what is the class mark of 0 to 19? This is simple. You have to answer.
9.5.
Yes.
9.5.
Yes, 9.5. For that, we have to know what is class mark is. Class mark is midpoint. Right? So how to calculate midpoint? Upper class plus lower class by 2. 0 plus 19 by 2, 9.5. For open end, okay, this is next part. We'll look into it later. Okay, so this is the first chapter. Clear with this?
Yes, sir.
Yes. Okay, fine. The next chapter, important chapter, measures of central tendency and dispersion, 10 to 12 marks for sure. Okay, so first we'll start with measures of central tendency. What is central tendency? Tendency of the given observation to cluster around that central value. That central value, calculation of that central value is called measures of central tendency. So it helps us in comparing different distribution. We have different measures of central tendency. Ideal measure, what should be the criteria for ideal measure? It should be properly defined. There should not be any ambiguity, easy to comprehend, simple to compute, based on all observation. Certain desirable mathematical properties, should be least affected by presence of extreme observation. So we have different types of measures of central tendency. First one is arithmetic mean. Arithmetic mean is simple. Total all the observation divided by number of observations. Summation x by n formula. We have to write these down at one place. That is what I was talking about. Summation fx by n in case of grouped frequency distribution. Alternatively, we have some shortcut method. A plus summation fd by n into c. Do we have to remember this and apply this in the exam? The answer is no. We need not apply this. However, we have to remember this formula. In some cases, indirect questions can be asked. So in such cases, we may have to look into this formula. So direct questions, if they ask, we may not apply that. We can directly apply the normal formula. However, some indirect questions can be asked. So in such cases, we may have to use this shortcut formula as well. A is the assumed mean. We'll assume some mean, right? So this is normal calculation. Calculations can also be asked, but more than that, properties are important. If all observations are constant, then arithmetic mean is also that constant. So if we have only 5, if we have 6 values of 5, arithmetic mean is 5 itself, right? And algebraic sum of deviations of set of observation from their arithmetic mean is 0. So x, we will calculate x bar, then you calculate x minus x bar. Total of x minus x bar will always be 0. Summation x minus x bar will always be 0. In case of frequency distribution, summation f into x minus x bar will always be 0. This will be asked. See how it will be asked is practical question will be asked. They'll give you some values of x. They'll ask you to calculate x minus x bar. So summation x minus x bar. In such cases, we should not solve. We should not calculate x bar, calculate x minus x bar, etc. We should apply this property and directly tick 0 as the answer. Arithmetic mean is affected due to change of origin and change of scale. So all measures of central tendency gets affected by change of origin and change of scale. Measures of dispersion gets affected by change of
Origin.
Origin.
Scale.
Scale.
Obviously, if it is not origin, it should be scale. Yes, so measures of dispersion gets affected by change of scale, not origin. So since they get affected by change of origin as well as change of scale, if the two values are related by a, y is equal to a plus b into x, y bar will be equal to a plus b into x bar. So y median will be equal to a plus b into x median. Y mode will be equal to a plus b into x mode. Right? So this can also be asked. This is a property. And combined mean. So if we have n1 values, x1 bar is the arithmetic mean, n2 values, x2 bar is the arithmetic mean. How do we calculate the combined arithmetic mean? n1 x1 bar, n2 x2 bar divided by n1 plus n2.
Plus n2.
This can be used. This I'm giving the example for 2. It can be used for n number of observations. That can be used for any number of observations. So more than 2, we have to just add all the arithmetic means that we have. That is about mean. Then median we call it positional average because it is not based on some calculations. It is based on the position, the middlemost value of any observation when it is arranged in ascending or descending order is called median. If we have 2, that is in case of even numbers, we will have 2 middlemost values. We calculate the average of it for calculating median. However, in case of frequency distribution, we go with this formula: L1 plus n by 2 minus NL divided by NU minus NL into C, where L1 is the LCB of the median class, not LCL, LCB, lower class boundary of the median class. So for that, what we have to do? First, we have to identify median class. How to identify median class? We want cumulative frequency. Ideally, go with less than cumulative frequency. Less than cumulative frequency, calculate n by 2. Calculate n by 2, locate that n by 2 value in the cumulative frequency. That particular class interval is the median class. So once we have identified the median class, you will have lower class boundary of that median class, which is L1. N by 2 you have already calculated. What is NL? Less than cumulative frequency of
preceding class.
Yes, preceding median class. NU is the lower LCF of that median class. C is width of the class. Width of the median class. So with this, we get the median. This formula is very important because the same formula we use in quartiles as well. The same formula we use in quartiles as well. Having said that, again, properties of median important. First property we have already discussed: change of origin, change of scale. So y is equal to a plus bx relationship. Next property is very important. For a set of observation, sum of absolute deviation is minimum when deviation are taken from median. In mean, we had discussed summation x minus x bar is equal to 0. In median, they are saying summation absolute deviation, modulus of x minus median. Modulus of x minus median will be the minimum value that we get. So when we calculate modulus of x minus mean, x minus median, x minus mode, which is the lowest value? X minus median. So the sum of absolute deviation would be minimum when the deviation is taken from
Median.
When the deviation is taken from median. So this is median. Extended version of it is partition values, quartiles, fractiles, the deciles, percentiles, etc. Right? So what are partition values? They divide the entire observation into multiple equal parts. So if we have 2 equal parts, we have median, 4 equal parts quartiles, 10 equal parts deciles, 100 equal parts percentiles. For 100 equal parts, we have 99 percentiles, not 100 percentiles. Correct? So how do we calculate? Simple. In case of ungrouped data, we go with ascending or descending order, same as median, right? And we go with n plus 1 into p. N plus 1 into p to calculate the requisite quartile, percentile, decile, etc. So if I want D3, how do I calculate? If I have 10 observation, 10 plus 1 into 3 by 10. 10 plus 1 into 3 by 10, because this is decile. If I want percentile, P55, 10 plus 1 into
55
by 100.
55 by 100. Yes, that is how we will calculate partition values in case of ungrouped data. In case of ungrouped data. In case of grouped data, the same formula that we had in median. Instead of n by 2, we go with NP. What is NP? N by 2 into P. Sorry, N into P. Sorry, not N by 2 into P, N into P. What is n? N is the number of observation. P depends on the requisite partition value that we require. So if we require D3, if we have 100 values, 100 into
3 by 10.
3 by 10. That would be the NP value. Clear?
Yes, sir.
Yes. So other values remain the same. L1, NL, NU, and C would remain the same. Now, another way, apart from this formula, another way is using ogives, the way that we had discussed in the previous chapter. How do we calculate quartiles using ogives? First, draw the less than type ogive. Then draw a line parallel to horizontal axis through the point NP. So I have less than type ogive. Then I'll calculate NP value. Let's say I want D3. So I have calculated the requisite NP value. That NP value, I'll draw a horizontal line. The point at which it intersects this point, first I'll draw a horizontal line. This point where perpendicular to x-axis, this point is the D3 value. So this is how I calculate quartiles using ogives. How I calculate quartiles using ogives. So that is partition values. Next one is mode. What is mode? The value which has occurred the maximum number of times. Very simple. So if there are no values with repetition, then that particular frequency distribution or particular class of data does not have any mode. No mode itself at all. However, in certain cases, there could be more than one mode as well in a distribution. So we call such distribution as multimodal distribution. If we have two mode, we call it bimodal distribution. We call it bimodal distribution. So in case of ungrouped data, it is simple. We'll have the data presented, identify the observations having which has highest repetition, that would be the mode. But in case of group distribution, what do? We have a formula. First, what we have to do, we have to identify modal class. What would be the modal class?
The class corresponding to the highest frequency.
Highest frequency, correct. Class corresponding to highest frequency would be modal class. Once you have identified modal class, you have to apply this formula. Same L1 plus, here it would be FO minus F1 divided by 2FO minus F minus 1 minus F1 into C. F0, FO is frequency of modal class. F1 is frequency of
pre-model class.
This should be F minus 1. F minus 1 is frequency of pre-modal class. F1 is frequency of post-modal class. Next. And C obviously is the width of the class interval. So I have various class intervals. If this is a modal class, this frequency is F0, this is F minus 1, this is F1. Correct? And L1 is what? LCB of the modal class, lower class boundary. Coming to the properties, same property, y is equal to a plus bx, change of scale and change of origin. So with regard to mean, median, and mode, we have one important relationship. We call it empirical relationship. Mean minus mode is equal to 3 into mean minus median. Will be asked in the exam. Okay, not the equation, practical examples. They'll give you mean and median. They'll ask you to calculate mode and vice versa. So mean minus mode is equal to 3 times of mean minus median. Alternatively, mode is equal to 3 median minus 2 mean. This is the empirical relationship, which we have to write it down along with the formulas for last minute revision. Next one, geometric mean. Geometric mean is calculate the product of all the observations, then calculate the nth root of it. So nth root of product of all the observations is geometric mean. So practical question, calculation of geometric mean may not be asked. However, properties are very important. How do we calculate the geometric mean in case of grouped distribution? First, you calculate that particular value corresponding frequencies power. So x to the power of x1 to the power of f1 into x to the power of f2 into x3 to the power of f3. To this, you calculate nth root. We get geometric mean in case of grouped data. So if we have not understood, nothing to worry about it. It will not be asked, don't worry. Properties of geometric mean is very important. Okay, logarithm. Now I have geometric mean that I have calculated. I want to calculate logarithm value of that geometric mean. That will be equal to logarithm values of the x values based on which you have calculated geometric mean divided by the number of observations. So you have 5 observations, 2, 3, 4, 5, and 6. you have calculated geometric mean. How did you calculate geometric mean? 2 into 3 into 4 into 5 into 6 to the, what root we have to do? Fifth root, 5 values, fifth root. So based on that, you would have got geometric mean. So let's say we got geometric mean of 3.5. Obviously, it's not the geometric mean. Now on this I have to calculate log. How to calculate log of 3.5? One, we can use log tables and calculate log 3.5. Alternatively, you have 2, 3, 4, 5, 6. Calculate log of these values, log 2, log 3, log 4, log 5, log 6. Total of this divided by 5. You get logarithm of G. That is the first property. Logarithm of geometric mean of set of observation is arithmetic mean of logarithm of the observations. If all the observations assumed by variable are constant, geometric mean is also that observation. If all the observations are 2, 2, 2, 2, 2, geometric mean is also 2. Logical. Geometric mean of two variables. Now, I know Z is equal to X into Y. What would be geometric mean of Z? It would be geometric mean of X into geometric mean of Y. Similarly, I know Z is equal to X divided by Y. Geometric mean of Z will be equal to geometric mean of X divided by geometric mean of Y. Clear? Right? These are the properties, important properties of geometric mean. The last one in measures of central tendency is harmonic mean. So what is harmonic mean? The formula says reciprocal of the arithmetic mean of reciprocal of the observation. So don't worry about the definition. It is simple. Harmonic mean is n divided by summation 1 by x. So summation x by n is arithmetic mean. Take it to the denominator, put it upside down, 1 by x. Summation 1 by x. N, bring it to the numerator. So n divided by summation 1 by x is the harmonic mean. N divided by summation 1 by x is the harmonic mean. In case of group distribution, it would be capital N divided by summation, instead of 1 by x, you do f by x. That's all. N divided by summation f by x. Again, properties are important. If all observations are constant, harmonic mean is also the same value. Combined harmonic mean can be asked. Okay, in combined arithmetic mean we had discussed. Similarly, combined harmonic mean n1 plus n2 divided by n1 by h1 plus n2 by h2. In arithmetic mean, what was combined arithmetic mean? n1 x1 bar plus n2 x2 bar divided by n1 plus n2. Here, bring this to the numerator, bring this to the denominator, x bar, bring it further down. So n1 h1 plus n2 by h2. That is combined harmonic mean. Now, when do we use harmonic mean? Whenever they ask calculation of average of speed, rate, we have speed, we have to go with harmonic mean. Whenever they ask us average of rates, we have to go with geometric mean. Right? So they will not ask directly calculate harmonic mean. They'll just give you two speeds. Average speed of moving from A to B is so and so. Coming back from B to A is so and so. What is the average speed? We have to apply harmonic mean, not the normal arithmetic mean. Is that clear? Okay.
Sir?
Yes. Yeah.
Sir, why exactly do we do that?
Because harmonic means, that is the speed, the concept of speed follows the concept of harmonic mean. The normal average cannot be applied because speed is a component of distance and time, right? Physics again. So it's distance and time. So it will have multiple components involved in it. So normal arithmetic mean cannot be applied. We have to go with harmonic mean. It follows the properties of harmonic mean, speed.
Okay, sir. Thank you, sir.
Now, having said that, there is a relationship, important relationship between our AM, GM and HM. GM square, geometric mean square is equal to arithmetic mean into harmonic mean. Again, can be asked practical questions. And at all times, arithmetic mean greater than or equal to geometric mean greater than or equal to harmonic mean. So two important properties that we have to consider. Then we have a small discussion, weighted average. In case there is a hierarchical order of importance, we go with weighted average. Weights is nothing but frequency, right? Weighted arithmetic mean summation wx by summation w. Weighted geometric mean anti-log of summation w log x by summation w. Harmonic mean weighted summation w divided by summation w by x. When to use arithmetic mean, geometric mean, harmonic mean? Normally use arithmetic mean. In case of rates, percentage, etc., use geometric mean. In case of speed, use harmonic mean. Comparison, which is the best measure of central tendency? Arithmetic mean. Why? It is rigidly defined based on all observation, easy to comprehend, simple to calculate, amenable to mathematical properties. What is the disadvantage? Affected by sampling fluctuation. So and in case of open-end class intervals, we cannot apply arithmetic mean. What is open-end class interval? First class interval will be open-ended, less than 80, less than 100, or last class interval will be open-ended, more than 1000. So it could go up to infinity. There is no upper limit there. Here, there is no lower limit here, right? So those are open-ended class intervals. There we cannot get midpoint, so we cannot calculate arithmetic mean. This drawback is overcome by what? Median. Median is the best measure in case of open-ended class intervals, can be asked. Like arithmetic mean, median is also rigidly defined and easy to comprehend and compute, but median is not based on all observations and does not allow itself to mathematical treatment. Median is middlemost value, so it's not based on all observations. Disadvantage. But advantage is median is not affected by sampling fluctuation. Disadvantage of arithmetic mean, overcome by median. It is the most appropriate measure of central tendency for open-end classification. Disadvantage of arithmetic mean, overcome by median. Although mode is the most popular measure of central tendency, there are certain cases where mode remains undefined. We have discussed, right? In certain cases, if there is no repetition in the values, there will be no mode. Similarly, there can be multiple modes as well. So there is no consistency, right? So it has no mathematical property. Mode is also affected by sampling fluctuation. Now, similar to arithmetic mean, geometric mean and harmonic mean, they have mathematical properties, but they are used in advanced discussions. They are rigidly defined based on observations, but they are difficult to calculate and comprehend. That is the disadvantage of geometric mean and harmonic mean, and they have limited applications. They have limited application. This is measures of central tendency. Clear?
Yes.
Yes. Okay. Can we take a 5-minute break?
Yes, sir.
Yes, sir.
Okay. Come back at 8:22.
Okay.
We'll continue. Okay, friends, are we back?
Yes, sir.
Yes, sir.
Yes, sir. Yes, sir.
Yes. Okay. So, have we heard of Muthoot Finance?
Yes,
Yes,
sir.
sir.
Yes.
Yes, sir.
Okay. Can we have a look on the board of directors of Muthoot Finance?
Sure, sir.
Okay. Chinmay, read the director names.
Board of Directors, George Jacob Muthoot, Chairman, George Alexander Muthoot, Managing Director, George Thomas Muthoot, Whole-time Director, Alexander George, Whole-time Director, George M. George, Whole-time Director, George M. Jacob, Whole-time Director, George Alexander, Whole-time Director.
Yes. So, who's calling whom? God knows.
Sir, we are doing permutation combination now, sir.
Yes. They have used mathematics concept of permutation combination.
Where and how?
In naming.
Oh,
George, first name, second name, middle name. Okay, fine. We'll continue. Measures of dispersion. The next discussion. Measures of dispersion. Second important characteristic is measures of dispersion. What is dispersion? Dispersion is the variation that would be there among the data that we have, right? So it's an important measure of the identifying the measure that particular class interval, that frequency distribution. Why? Because there could be multiple frequency distributions with the same arithmetic mean, but there could be different measures of dispersion. Standard deviation, mean deviation, etc. could be different, right? So it's again important. We have different categories of measures of dispersion. One is absolute measures of dispersion, relative measures of dispersion. Absolute measures for range, mean deviation, standard deviation, quartile deviation. Range, coefficient of range. Mean deviation, coefficient of mean deviation. Standard deviation, coefficient of standard deviation, also called as coefficient of variation. Quartile deviation, coefficient of quartile deviation. What is the difference between this absolute measure and relative measure? Absolute measure would be in the respective units, right? Dependent on the unit of the variable. Whereas relative measure are in percentages, so they are unit free. Absolute measures, we cannot compare two or more distributions. If one of the distribution is in kgs, the other distribution is in liters, we cannot compare the standard deviation that we have calculated, the range that we have calculated. Whereas in case of relative measures, since they are in percentages, we can compare it easily, right? So it can be compared. Comparison becomes possible. And absolute measure are easy to compute and comprehend, whereas relative measure are difficult to compute and comprehend because there is some additional steps that we have to follow. Characteristics of an ideal measure, same as measures of central tendency. The characteristics that we have discussed, it should be properly defined, no ambiguity, easy to comprehend, easy to compute, based on all observations, unaffected by sampling fluctuations, amenable to some desirable mathematical treatment. However, none of the measures of central tendency or measures of dispersion for that matter satisfy all of the characteristics. Obviously, that is the reason we'll have multiple measures of dispersion and central tendencies, which we will use appropriately depending on the situation. The first one, range. What is range? Difference between largest and smallest. Simple, right? H minus L, highest minus lowest, or L minus S, largest minus smallest. It's appropriate. It's the coefficient. It's absolute relative measure. The coefficient of range is L minus S that we have calculated divided by L plus S into 100. L minus S by L plus S into 100 is the coefficient of range. Now, for a grouped frequency distribution, range is okay. In case of ungrouped data, we can calculate range. In case of group data, how do we calculate range? First class intervals, lower class, limit or boundary? Boundary. Lower class, boundary. Right? Last class intervals, upper class, boundary. Difference between the two would be the range in case of grouped frequency distribution. Since range is based on only on two observations, it is not considered ideal way because not all observations are involved. Only two, highest and the lowest observations are considered, and all measures of measures of dispersion gets affected by change of scale only. They don't get affected by change of origin. I hope we understand by change of origin and change of scale. We did not go back to that basics, right? So since they only get affected by change of scale, range of y can be calculated by modulus of b into range of x when y is equal to a plus bx. When y is equal to a plus bx, we go with this b value, modulus of that, ignore the sign, multiplied with the range of x, we get the range of y. That is range. Mean deviation, it is calculation of mean, that is total number of observation divided by total number of values. But what observations? It is the deviation of the observations from a appropriate measure of central tendency. It could be mean, median, mode, etc. So if we use mean, mean deviation about mean. If we use median, mean deviation about median, and so on. Right? So A represents the appropriate measure that we are considering. So summation modulus of x minus A divided by n. If it is of grouped frequency, multiply it with f frequency. Correct? So that is how we have that is what we have discussed. Coefficient of mean deviation would be mean deviation that you have already calculated divided by that value of central tendency that you have used. If you have calculated mean deviation about mean deviation divided by x bar into 100. If you have calculated mean deviation about median deviation divided by median into 100. That is coefficient of mean deviation. Clear? What are the properties? One of the property is change of scale. So same, mean deviation of y is modulus of b into mean deviation of x. Mean deviation takes minimum value when deviation is taken from mean or median.
Absolute median.
Yes. Since we are taking absolute deviation here, it would be minimum when the deviation is taken from median, property that we have discussed in case of median. So mean deviation will be minimum when the deviation is taken from median. So mean deviation about median would be lower than mean deviation about mean. Then what is the disadvantage? It is difficult to compute and no mathematical treatment possible. However, when compared to range, it is a better measure. Now, what is the ideal measure of dispersion? Standard deviation, the best measure of dispersion. Best measure of central tendency is arithmetic mean. Best measure of dispersion is standard deviation. Standard deviation does not possess the demerits of range and mean deviation. What is standard deviation? Root mean square deviation when the deviations are taken from arithmetic mean. So that is summation x minus x bar the whole square divided by n square root. If it is grouped frequency, summation f into x minus x bar the whole square by capital N square root. Now, if we do not take the square root, we call it variance. If we take the square root, we call it standard deviation. The most useful measure of dispersion, most commonly used. It has some desirable mathematical properties and can be used to find a pool of measure of dispersion. Combining, we can calculate combined standard deviation, right? And its relative measure of that is coefficient of relative measure is coefficient of variation, that is sigma by x bar into 100, standard deviation by arithmetic mean into 100. Similar to arithmetic mean, where we had an alternative method, shortcut method that we call. Similarly, here also we have an alternative method, summation fd squared by n minus summation fd by n the whole square, where d is x minus a by c. A is again that assumed mean that we had taken in arithmetic mean shortcut method. Again, we need not use this in the examination. However, we may have to remember this. Theoretical question can be asked. What are the properties? If all the observations are constant, what is the measure of central tendency that we get? If all the observations are 2, what is the arithmetic mean? 2. Similarly, if all the observations are 2, what is the standard deviation?
0.
0, because there is no deviation at all, right? So standard deviation would be 0. If all the observations are constant, standard deviation is 0. Standard deviation remains unaffected due to change of origin, but only change of scale. So standard deviation of y is modulus of b into standard deviation of x. Combined standard deviation. So we have same combined arithmetic mean related n1, n2, x1 bar, x2 bar, and s1 and s2 are the standard deviations. How do we calculate combined standard deviation? Root of n1 s1 square plus n2 s2 square plus n1 d1 square plus n2 d2 square whole divided by n1 plus n2. Now we understand by n1 s1 n2 s2. What is this d1? D1 is the difference between arithmetic mean of first group minus combined arithmetic mean. D2 is difference between arithmetic mean of second group minus combined arithmetic mean. So if x1 bar and x2 bar are equal, then combined arithmetic mean will also be equal. In such cases, combined arithmetic mean will be n1 s1 square plus n2 s2 square divided by n1 plus n2. This will not be there. So normally we'll have this because x1 bar and x2 bar will not be the same, will be different. So we get a different combined arithmetic mean. So we'll have d1 and d2 values. However, if x1 bar and x2 bar are same, where in such cases we'll have n1 s1 square plus n2 s2 square divided by n1 plus n2 root as the combined standard deviation. That is combined standard deviation. Last measure of dispersion is quartile deviation. Quartile deviation provides the best measure of dispersion for what? For open-end classification. There, median is the best measure of central tendency for open-end classification. Similarly, quartile deviation is the best measure for open-end classification. Less affected due to sampling fluctuation because it does not include all the values. And it does not affected due to change of origin, but only change of scale. How do we calculate quartile deviation? Q3 minus Q1 by 2. Simple. Q3 minus Q1 by 2. Coefficient is Q3 minus Q1 by Q3 plus Q1 into 100. Similar to range. Range is L minus S divided by L plus S. Same. Q3 minus Q1 by Q3 plus Q1 into 100. That is quartile deviation, coefficient of quartile deviation. So with this, we are done with measures of central tendency, measures of dispersion. What are important in this chapter? Formulas, properties. Formulas and properties are important. Any doubts in this?
Sir, in the exam, will they ask us to calculate that missing frequency and also like we used to have in first PU and all? Missing frequency.
Missing frequency can be asked. Missing frequencies can be asked, yes.
Sir, but that is a long question. So how can we solve it under?
Correct. See, simple calculations will be asked. Not obviously time-consuming questions definitely will not be asked. Simple questions, however, still can be asked in case of missing frequencies kind of a thing. Okay. We'll look into some questions. For open-end classification, which is the best measure of central tendency?
Median.
Quartiles are 45, 50 to 65. What is quartile deviation? What is the quartile deviation? Quick.
Option B, sir.
Option 20. So how did we get that? Q3 minus Q1. Quartile deviation is what? Q3 minus Q1 by 2. 65 minus 45 divided by 2. 10 is the correct answer, right? Formula is important. Then x and y are related by y is equal to 2x plus y. Standard deviation and arithmetic mean of x are known to be 5 and 10. Then what is the coefficient of variation of y? Not x, coefficient of variation of y. Relationship, using relationship, calculate the standard deviation of y, y bar, and then calculate coefficient of variation. 1 minute. Okay, so y is equal to 2x plus y. We know standard deviation of x is 5. What is the relationship? Standard deviation of y is modulus of b into standard deviation of x. What is modulus of b?
2 into 5, 10.
B is 2, right? So 2 into 5. Standard deviation of y is 10. Standard deviation of y is 10. Now we want x bar. Y is equal to 2x plus 5. So y bar will be equal to 2 into 25. X bar plus 5. X bar is 10. So 2 into 10 is 20. 20 plus 5 is 25. So y bar is 25. Standard deviation of y is 10. Coefficient of variation is standard deviation by arithmetic mean into 100. 10 by 25 into 100.
40 plus
40. That's all. Then for moderately skewed distribution, median is twice the mean. Then mode is dash times the median. What we have to use here?
Empirical relation.
Perfect. Empirical relationship. Empirical relation, mode is equal to
B median minus 2.
B median minus 2 mean. They have given median is 2 times mean. So 2 mean is equal to 1 median.
Yes, sir.
Correct. So 3 median minus 1 median, mode is equal to 2 median. So mode is 2 times the median. Simple. Then average marks for a group of 30 girls is 80, group of 7 boys is 70, combined average is 76. How many boys are there in the group? So they have given us N1, X1 bar. They have not given us N2. They have given us X2 bar. They have given us combined arithmetic mean. We have to find out what N2 is using the formula of combined arithmetic mean. N2 is question mark. X2 bar is 70. X bar arithmetic mean is 76. So 76 is equal to 30. N1 X1 bar 30 into 80 plus N2 into 70 divided by N1 plus N2 is 30 plus N2. Correct. So 76 into 30 plus N2 is equal to 30 into 80 is 2400 plus 70 N2. Multiply. What is 76 into 30? 2280 plus 76 N2 is equal to 2400 plus 70 N2. This bring it this side, 2280, send it the other side. 76 N2 minus 70 N2 is 6 N2 is equal to 2400 minus 2280 is
120.
N2 is 120 by 6, 20.
20.
That's it. Median value of the set of observation. This is simple. Calculate the median for this.
61.
Yes, correct. So what is the first step that we have to do? Arrange it in ascending or descending order. So we get 19, 36, 48, 56, 66, 72, 87, 91. So total number of values 8. So we'll have two middlemost values, 56 and 61. How do we calculate median? Average of it. 56 plus 66 by 2, 61 is the median. Two variables A and B are related by C is equal to AB. What is the geometric mean of C?
Option B.
Yes, geometric mean of A into geometric mean of B. Geometric mean of A into geometric mean of B. If there are three observations, 15, 20, and 25, sum of the deviation of the observation from their arithmetic mean?
0.
Yes, the property, summation x minus x bar. We should not calculate here. Straight away answer, 0. Mean weight of 15 students is 110 kg. Mean weight of 5 of them is 100 kg. Another 5 of them is 125 kg. Mean weight of remaining students. What is the concept that we have to apply here?
Combined
Combined arithmetic mean. So we know 110 is the total combined arithmetic mean. 5 students mean weight is 100. So 100 into 5 plus 5 students 125. 5 into 125. What is the balance number of students remaining?
5.
5, total 15. So 5, the arithmetic mean we do not know. I'll take it as x divided by 15. Correct? So 15 into 110 we get 1650. 100 into 5 is 500. 125 into 5 is 625 plus 5x. Send this 5x other side. This is 1125. 1650 minus 1125. 5x is equal to 525. Therefore, x is
115.
105. X is 105. So that is the answer. If the arithmetic mean between two numbers is 64, geometric mean between them is 16, what is the harmonic mean? What is the concept that we have to use here?
G square equals
Yes.
M square equals AH.
Yes, correct. G square is equal to A into H. So by doing that, what is the harmonic mean that we get?
4.
What is G? 16. 16 square is?
256.
256. A is 64 into H. So H will be 256 by 64. 4. Simple. Then that's all. So these are some of the questions that we have with regard to measures of central tendency and dispersion. Yes. See, I'm not saying that this is how we have to solve. This is the speed that is expected, etc. We have to somehow reach to that speed. It's not that the exact speed that is expected. So at the end of the day, we have to complete 100 marks paper in 2 hours, right? So obviously we have to have that speed. Okay, I'm not creating tension here. It's just how we have to go. It's just giving an idea how we have to solve. Obviously, we have 7 days time to prepare. We can do it. We can always do it. Okay. Next chapter, probability. What is probability? Okay, before moving into probability, anyone has any doubts still here? Okay, which are the chapters for which we have to solve additional questions? Okay, additional questions in the material suggested not to solve, only if you have time. That extra cushion that I was saying, there you can go with additional questions. When you are solving additional questions, preferably solve additional questions in important chapters like measures of central tendency, theoretical distribution. These are important chapters in statistics. So go with those chapters where the number of questions in the examination would be higher. Others, any question? Okay. Next chapter, probability. Now, probability, again, game of chance. There are two types, subjective and objective. Subjective is purely based on decisions, personal decision, individual judgment and experience, whereas objective probability is based on predefined theories, right? So in our discussion, we are only going with objective probability. Now, before understanding the concept of probability, the theories in probability, we have to understand certain definitions. Experiment. What is experiment? The performance that we do to get some results. That is experiment. That performance wherein the result of that experiment, if it is purely based on chance, then we call it random experiment. If it is purely based on chance, we call it random experiment. Tossing of a coin, it's purely based on chance. If it is an unbiased coin, obviously, if it's a biased coin, it's not based on chance. Then we cannot call it random experiment, right? Rolling of a die, drawing cards, etc. They are random experiments. What are events? The results that we get in the random experiment are called events. So when we toss a coin, we might get a head or a tail. So getting a head is an event. Getting a tail is an event, right? So those are events. The results of an experiment are events. Events can be divided into two: simple event, compound event. So if an event cannot be further divided, we call it simple event. Tossing of coin once, either we'll get head or we get tail, full stop. So it's a simple event. Whereas getting one head when I toss a coin 2 times. In such cases, when I toss a coin 2 times, I can get first head, then tail, or I can get first tail, then head. Correct? So it can be further divided. Getting a head when 2 coins are tossed is an event, but that event can be further divided into 2 different events. Hence, we call it compound events. Hence, we call it compound events. That's the difference: simple event and compound event. Then mutually exclusive events or incompatible events. Mutually exclusive events are those events which cannot occur simultaneously. 2 events are called mutually exclusive, which cannot occur simultaneously. Tossing of a coin, head and tail, can they occur simultaneously? No. So they are mutually exclusive. Exhaustive events means those events out of which at least one event should occur when a particular experiment is conducted. So in case of tossing of a coin, we have 2 events, head and tail. They are exhaustive because either head or tail should occur, right? So that is exhaustive events. Equally likely events means the probability of occurrence of those events are equal. Hence we call it equally likely events. The events of a random experiment are known to be equally likely. When all necessary evidence is considered, no event is expected to occur more frequently when compared to other events. Again, same example, tossing of a coin or rolling of a die is also we can consider. We have equally likely events, 6 equally likely events we have in case of rolling of a die. Now, these are the definitions that we have to understand before moving on to the first concept in probability, which is classical definition. How do we calculate probability here? First, calculate the total number of events. Out of the total number of events, identify the favorable events. So favorable events by total number of events is the probability. Probability is number of favorable events divided by total number of events. However, this is simple, but what are the disadvantages here? It is applicable only when total number of events are finite, because my denominator should be finite. So total number of events are finite only then we can go with classical definition. It can be used only when events are equally likely or equiprobable. So all the events should be equally likely. This definition has only limited field of application, like tossing of a coin, all equally likely events, tossing of a coin, rolling of a die, drawing cards, etc. In case of uncertainty or where no prior knowledge is provided, we cannot apply this. Hence, we call it a priori definition. Prior knowledge of the events is compulsory. Right? The points to be noted: probability, minimum probability 0, maximum probability 1. If probability is 0, we call it impossible event. Probability is 1, we call it sure event, certain event. Right? Non-occurrence of event A, we call it A complement, A dash. Event A plus A complement, together we get exhaustive event, mutually exclusive events. Right? Event A and A complement are mutually exclusive and exhaustive. Therefore, probability of A plus probability of A complement will be equal to 1. Because they are exhaustive and mutually exclusive. They are exhaustive and mutually exclusive. Then odds ratio. That we have something called odds in favor and odds against. Right? What is odds in favor? Odds in favor is number of favorable events is to number of unfavorable events. Odds against is number of unfavorable events is to number of favorable events. So when we take an example, if probability of A is 1/3, probability of A complement will be 2/3. So what is odds in favor? 1:3 or 1:2? 1:2. Favorable is 1, unfavorable is 2. So 1:2 is odds in favor. Odds against is
3:1.
Yes.
So 2:1.
Unfavorable is to favorable. 2:1. Correct. So odds in favor and odds against. Then operations. This is the first part, classical definition. Then the second part of the discussion is operation on event, set theoretic approach, wherein the population is called sample space. In that, we'll have multiple events. Event A is a subset of S. So if there are two events, A and B, union of two events means all those events which are there in A as or B. So add up all events which are there in A and events which are there in B. Put together, we call it union of events. Intersection of events means events which are there in A and B, common events. Common events of A and B are called intersection. For mutually exclusive events, mutually exclusive, obviously there will not be common because they cannot happen simultaneously. So in such cases, intersection will be null set. It would be a null set. So probability of A intersection B in case of mutually exclusive events would be 0. Right? Mutually exclusive events would be 0. What is difference of two events, A minus B? Those events which are there in A but not in B. Those events which are there in A but not in B. So probability of A minus probability of common A intersection B. Right? That is probability of A minus B. Complement of event A is 1 minus A or S minus A. In case of set theoretic approach, we go with S minus A. Two events A and B are mutually exclusive. If probability of A union B is probability of A plus probability of B. If they are mutually exclusive, obviously no common events. So probability of A plus probability of B should be probability of A union B. Similarly, probability of A union B union C is P of A plus P of B plus P of C. If they are exhaustive, we say probability of A union B is equal to 1 because apart from A and B, there cannot be any other event because they are exhaustive events. If they are equally likely, we say probability of A is equal to probability of B is equal to probability of C because they are equally likely. If they are mutually exclusive and exhaustive, then probability of A plus probability of B plus probability of C will be equal to 1. All these relationships are important. All these relationships are important. So using this relationship, we have various axioms, right? Same thing what we have discussed. For mutually exclusive, P of A union B is P of A plus P of B. P of A union, A1 union, A2 union up to AK will be P of A plus P of A1 plus P of A2 plus P of A3 up to AK. Because they are mutually exclusive. We can keep on adding the probabilities. But if they are not mutually exclusive, in that case, P of A plus P of B minus P of A intersection B is the probability of A union B. So the difference we have to identify. P of A union B is P of A plus P of B in case of mutually exclusive. In other cases, it is P of A plus P of B minus P of A intersection B. P of A plus P of B minus P of A intersection B. Similarly, P of A union B union C in case of non-mutually exclusive, P of A plus P of B plus P of C minus P of A intersection B, P of A intersection B, A intersection C minus P of B intersection C plus P of A intersection B intersection C. One additional point, we should not miss this. So they can ask this also in the examination, right? So they can ask us to calculate A union B union C. So what we have to do? P of A plus P of B plus P of C minus P of A intersection B, A intersection C, B intersection C plus A intersection B intersection C. Clear?
Yes, sir.
Yes. Okay. Next is conditional probability. What is conditional probability? Joint probability. Simultaneous occurrence of two events. So P of A intersection B, that is conditional probability. That depends on whether the events are dependent or independent of each other. If they are independent of each other, we are not bothered. P of A intersection B is what?
0.
I'm not talking about mutually exclusive. In case of mutually exclusive, P of A intersection B is 0. But if they are independent events,
P of A into P of B.
yes, P of A into P of B. So in case of A union B scenario, union of events, we have mutually exclusive, non-mutually exclusive. In case of intersection of events, we have dependent events, independent events. Okay, we should not get confused. In case of dependent event, independent event, simple P of A intersection B is equal to P of A into P of B. But in case of dependent events, we have something called P of A intersection B is P of A into P of B given A. Alternatively, P of B given A is P of A intersection B divided by P of A. So how to remember this? So first we have to identify whether we require P of B given A or A given B. Numerator will always be A intersection B. Denominator, what is there in the second part? It is A, so P of A. If it is P of A given B, P of A intersection B divided by P of B, because this is the second part, so P of B. Okay, that is in case of dependent events. So in case of independent events, P of A intersection B intersection C is P of A into P of B into P of C. So if two events are independent, then the following are also independent: A and B complement, A complement and B complement, A complement and B. All events are independent of each other. So correspondingly, we have the same theorems. P of A intersection B is P of A into P of B given A. P of A intersection B intersection C is P of A into P of B given A into P of C given A intersection B. Why? Because they are dependent events. They are dependent events. In case of independent events, we have already discussed. Apart from these theorems, one important law, De Morgan's law, P of A union B is 1 minus P of A complement intersection B complement. Very important. We have to remember. We cannot miss this. P of A union B is 1 minus P of A complement intersection B complement. Similarly, P of A intersection B is 1 minus P of A complement union B complement. The other way around. That is also, this is De Morgan's law. Many times they have asked, they can ask this type of questions. So this is probability concepts with regard to union and intersection related theorems. Then the next part, the last part, which is again a continuation, we have a continuation in the next chapter, is random variable probability distribution. So till now we have discussed about calculation of probabilities. Now we are discussing about creating a probability distribution similar to frequency distribution. So what is probability distribution? It's again a distribution. In frequency distribution, we have frequencies. In probability distribution, we have probabilities for corresponding values of X. That values of X we call random variable. So for every corresponding value of random variable, we have corresponding probabilities. So this random variables, same discrete random variable, continuous random variable, the concepts remain the same. Probability distribution will be such that total of all the probabilities of all random variables put together should be 1, correct? And if it is for discrete, we call it probability density function. If it is for continuous, we call it probability mass function. Or reverse, it is reverse. For discrete, we call it probability mass. For continuous, we call it probability density, PDF, right? In case of frequency distribution, the average is called arithmetic mean. In case of probability distribution, the average is called expected value. Why? Because it's probability at the end of the day. So it's expected value. So in frequency distribution, we have xf, we calculate fx, summation fx divided by summation f, we get arithmetic mean. Here we have xp, probability. So we calculate x into p, same. We calculate the total of x into p. We calculate total of p, which is always equal to 1. So summation x into p divided by 1, which is always summation x into p. So summation x into p is expected value. Expected value is summation p into x. Expected value of x square would be summation p into x square. Right? What would be the variance? Variance is expected value of x square minus expected value of x the whole square. Similar to normal standard deviation variance that we calculate. Summation x square by n minus summation x by n the whole square. Similarly, expected value of x square minus expected value of x the whole square. This is variance. Root of variance is standard deviation. And the same concept of change of origin, change of scale will apply. Expected value gets affected by change of origin and change of scale. So expected value of y will be a plus b into expected value of x. And standard deviation of y will be modulus of b into standard deviation of x. Same concept of measures of central tendency and dispersion that we have discussed. Properties also will remain the same. Expectation of a constant of k is always k. Expectation of sum of two random variables. Now we have 5 and 7. So if I have to calculate expectation of 12, I can calculate expectation of 12 by calculating expectation of 5 plus expectation of 7. So e of x plus y will be equal to e of x plus e of y. Similarly, I have 3 and 4. I want to calculate expected value of 12. That is expectation of 3 into expectation of 4. 3 4s are 12, right? So that can be done. That can be done. Or if I want to calculate expectation of 2x, how can I do this? 2 into expectation of x. Expectation of k into x is k into expectation of x. Clear? These are the properties in case of expected value. This is probability. So what all we have discussed in probability? First, we discussed the classical definition, the normal definition, favorable events by total events, odds in favor, odds against the events. Then we looked into the set theory where we had union of events, intersection of events. We discussed the theorems, mutually exclusive, non-mutually exclusive, dependent and independent events. Then we went on to probability distribution where we have discussed about random variables and expected value calculation. That is what is there in probability. Clear? Any doubts in this? No?
No, sir.
Okay, fine. Can we solve some problems then?
Yes, sir.
Yes. Okay. Question number 79. For a probability of random variable of x, what is the standard deviation of x? How do we calculate standard deviation? We have just discussed expected value of x square minus expected value of x the whole square. For that, we want expected value of x and expected value of x square. How do I calculate expected value of x? I have x and p. I want px. How do I calculate expected value of x square? P into x square. So with this, I have to just calculate x, p, px, p into x square. Right? So x is 1, 2, 4, 5, and 6. 0.15. 0.25, 0.2, 0.3, 0.1. P into x is 0.15, 0.5, 0.8, 1.5 and 0.6. Total 3.55. P into x square. What is x square? 1 square is 1. 1 into 0.15 is 0.15. 2 square 4. 4 into 0.25 is 1. 4 square 16. 16 into 0.2 is 3.2. 5 square 25. 25 into 0.3 is 7.5. 6 square 36. 36 into 0.1 is 3.6. Total 15.45. Now e of x square is 15.45. E of x is 3.55. 3.55 the whole square. E of x square minus e of x the whole square. So 15.45. 3.55 the whole square is 12.6025, which we get 2.85. 15.45 minus 12.6025 is 2.85. But we do not have 2.85 here.
Square root.
Yes,
1.
what we have calculated is variance. right? What we have calculated is variance, E of x square minus E of x whole square. We want standard deviation, which is
1.69.
square root of 2.85, which is
1.69.
1.69. So 1.69.
Option C.
Yes, understood how to calculate?
Yes, sir.
Yes, sir.
Yes. So this is how we'll calculate. Then two events A and B. P of A is given, P of B is given, this is A union B. This is not A, this is A union B. How do we calculate P of A given B? I think we had discussed this in the class, if we remember. P of A is 3 by 5. P of B is 2 by 3. P of A union B is 3 by 4. So to get P of A given B, what we'll require?
A intersection.
Very good. A intersection B divided by P of B. So we want P of A intersection B. Using this given information, can we calculate A intersection B?
Yes, sir.
Yes, sir.
What is P of A intersection B?
P of A plus P of B minus P of A.
Minus P of A.
Correct. P of A
31
plus
by
P of B minus
16.
P of A union B, which is 3 by 5 plus 2 by 3 minus 3 by 4.
3 by 4.
So I think 60 should be the LCM. So 12 3s are 36, 22s are 40, 15 3s are 45. So 36 plus 40 minus 45, 76 minus 45, 31. 31 by 60 is P of A intersection B. Then straight away apply. 31 by 60 divided by what is P of B? 2 by 3. So 31 by 60 into 3 by 2. 3 ones are 3 20s are 31 by 40. Do we have 31 by 40? 31 by 40 is not there. Check with the decimal. What is 31 by 40?
0.775.
0.775. So this is the answer. 0.775. Then 2x plus 3y plus 4 is equal to 0. Variance of x is 6. What is variance of y? This is expected value concept in that change of origin, change of scale concept. So they have given us variance of x as 6. How do we calculate variance of y? Now we have discussed standard deviation of y is modulus of b into standard deviation of x. That holds good even in case of expected value. Correct? So 2x plus 3y plus 4 is equal to 0 can be written as 3y is equal to minus 2x minus 4, or y is equal to minus 2 by 3x minus 4 by 3. Correct? So what is standard deviation of y? They have given us standard deviation of x. What is standard deviation of x? This is variance, not standard deviation. So standard deviation of x is root 6. Root 6 standard deviation of x. That relationship doesn't hold good for variance. It only holds good for standard deviation. So standard deviation is root 6. Modulus of b is
2 by 3.
2 by
2 by 3. So standard deviation of y is 2 by 3 into root 6. Whereas we want variance of y. Variance of y will be 4 by 9 into 6 square. 2 square 4, 3 square 9. Root of 6 is 6. Right? Correct? So 3 2s are 3 3s are. So 8 by 3. 8 by 3 is the answer. Then x and y stand in a line with 6 other people. What is the probability that there are 3 persons between them? It's a standard question. Okay. So x and y stand in a line with 6 other people. What is the probability that there are 3 persons between them? So what is the total number of events here? Total number of events is 8 people standing in a line. How many number of times it can happen? 8 factorial times. Right? So 8 factorial, which is 40320, is the total number of events. What is the favorable number of events? What do they want? 1, x and y are there. 6 other people are there. Out of 6 other people, they want 3 people to be in between x and y. Correct? So x should be there. 3 people should be there in between. Y should be there. Then the other 3 people can be there this side or that way. That doesn't matter. So we have 4 different set. X, the 3 people set. Y, the other 3 people set. Correct? Right? So out of the 6 people, we want 3 people. in between X and Y. That can happen in 6p3 ways, permutation, because out of 6, we want 3. This is not number of ways happening. So 6p3. Then this arrangement will happen in this 4 manner. X will be there, 3 people will be there, Y will be there, again 3 people will be there. So this can happen in 4 factorial different ways. These 4 different events can happen in 4 factorial different ways. And X and Y, X can be here, Y can be there. So they can be interchanged. So this can happen in 2 factorial ways. So this is the favorable number of events. 86p3 into 4 factorial into 2 factorial divided by 40320. If you have not understood, don't worry. Don't break your head. If you have understood, well and good. Okay. So by further simplifying this, we get 5760 divided by 40320, which is 1/7. If required for the benefit, I'll explain once more. Here, there are 8 people who are standing in a line. Therefore, it can happen in 8 factorial different ways. Right? Total number of events is 8 factorial. What is the favorable number of events? What is required here? X and Y are there. 3 people should stand in between X and Y. So there are 6 people, out of them 3 people should stand. So that can happen in 6p3 ways. I have to get 3 people out of 6. So that is 6p3 ways. Then X will be there. Those 3 people will be there. Y will be there. The other 3 people can be here or here in any other manner. Right? So X is one set. These 3 people is second set. Y is third set. These 3 people is fourth set. So these 4 can be arranged in 4 factorial different ways, because this can be here, X and Y can be here. So it can happen in 4 different factorial ways. And again, it doesn't mean that X and Y should be in the same order. They also can be interchanged. X can come here, Y can go here. So that is 2 factorial ways. So 6p3, 4 factorial, 2 factorial divided by 8 factorial is the probability. Okay, so obviously there will be these kind of questions in the exams, but very few. Okay, 4 to 5 questions out of 100. So don't bother about those questions. If you're not understanding, leave those questions. Nothing to worry. If you're not understanding, if you're understanding, please attempt. Then 4 unbiased coins are tossed simultaneously. What is the expected number of heads? What are we calculating? What are we supposed to calculate here?
Expected
Value. Simple.
Number.
We have X, we have P of X. We have to just calculate P into X and get the total. We get the expected value. Correct? Simple. Assume that the probability for rain on a day is 0.4. Umbrella salesman can earn 400 per day in case of a rain on that day, and will lose 100 if there is no rain on that day. Expected earnings. What is the expected earnings? So what are the different values of X? What is the amount that he receives if there is a rain?
400.
400. What is the amount that he loses if there is no rain?
100.
100. Loss of 100. So what is the probability that he gets 400 rupees?
0.4.
0.4. Probability of rain is 0.4. What is the probability of not raining?
0.
0.6. Probability of raining is 0.4. Probability of not raining is 0.6. Should be. So X into P of X would be 400 into 0.4 is 160. 100 into 0.6 is 60. 100 rupees is the expected value. That is the expected amount that is expected to get. Right? That's all. Okay. We have one more, I think. What is the probability of getting 3 heads if 6 unbiased can? Okay, this is not probability, it's a theoretical probability distribution. We'll look into that separately. Okay, this is about probability. Next, extension of probability, theoretical distribution. Now, first chapter we discussed probability distribution. Here, sorry, what did we discuss? Frequency distribution. Here we have probability distribution. Why we call it theoretical distribution? Because these probability distributions are based on various theories. Hence we call it theoretical distribution based on theories, right? Theoretical distribution, 2 types: discrete distribution, continuous. Discrete distribution, we have binomial distribution and Poisson distribution. Continuous, we have normal distribution. In binomial distribution, binomial is most frequently used. It is derived from random experiment called Bernoulli process. If the following conditions are satisfied, then only we can apply binomial distribution. These conditions are important. There should be, each trial should have two mutually exclusive and exhaustive outcomes. Two mutually exclusive and exhaustive outcomes. Occurrence of one is called success and non-occurrence is called failure. Occurrence of one is called success, non-occurrence is of failure. So we'll take the example of tossing of a coin. If we get head, if getting head is success, then the other one getting tail is failure. Similarly, rolling of a die, if getting 2 is success, then getting other numbers is failure. So there are only two mutually exclusive outcomes. Cannot happen simultaneously. Two exhaustive outcomes. Either there should be success or there should be failure. And the trials are independent of each other. Probability of success is P. Probability of failure Q, which is 1 minus P, remains constant throughout. And number of trials is a finite positive integer. Number of trials is a finite positive integer. So n, number of trials n is finite. It should be countable. If these conditions are satisfied, then only we can apply binomial distribution. Right? What is the formula or the relationship to calculate binomial, the probability in binomial distribution? NCX, P to the power of X, Q to the power of
n minus x.
Yes, where n is the total number of values, x is the number of success that we require, P is probability of success, Q is failure, probability of failure. Right? So what are the properties in binomial distribution? Total of all the probabilities should be equal to 1. Binomial distribution is biparametric. What are the two parameters?
N and p.
N and
Yes,
P.
n and p. Right? Mean of binomial distribution is n into p. Variance is n into p into q. So in binomial distribution, mean is always greater than variance. Why? Because q is lesser than 1. So n into p into q means variance will always be bound to be less than mean. Mode, two types. It depends on whether n plus 1 into p is an integer or not. If n plus 1 into p is a non-integer, then we have unimodal distribution. There will be only one mode. The highest value in n plus 1 into p will be considered as mode. That is, let's say probability is 0.5, n is 10. So 10 plus 1 into 0.5 is 11 into 0.5, 5.5. Is it an integer or non-integer?
Integer.
It's a non-integer.
Non-integer.
It's a non-integer, right? We have decimals. So it's a non-integer. In case of a non-integer, we have only one mode. What is the mode? The highest integer included in this. What is the highest integer included? 5. So 5 is the mode. However, if we get non-integer, if we get an integer, if n plus 1 is an integer, then we have two modes, bimodal. So let's say n plus 1 into p, we get 5. In such case, what are the two modes? N plus 1 into p, that is 5, and
4.
n plus
N
1 into
plus
p minus 1,
minus 1.
5 minus 1, 4. So that value and its previous value will be considered as mode. That value and its previous value will be considered as mode. Clear?
So if it was 5.6,
If it was 5.6, also 5, the largest integer. We should not round it off to next number. Till 5.99 also we have to consider 5 only.
okay, sir.
Okay, variance we have discussed. When will the variance of a binomial distribution is maximum? When p is equal to q is equal to 0.5. In that case, variance is maximum and the maximum value of the variance is n divided by 4. Why? N into p into q. 0.5 is 1 by 2, 1 by 2. So n into 1 by 2 into 1 by 2 is 1 by 4. So n divided by 4 is the maximum value of variance that we get. Since p and q are numerically less than 1, npq is always less than np. Therefore, variance of a binomial variable is always less than mean. This is important. Binomial distribution is symmetrical at p is equal to 0.5. This is also important. And if two distributions are following binomial distribution, if we add those two distributions, the resultant distribution also follows binomial. If x and y follows binomial distribution, x plus y also will follow binomial distribution. Okay, where do we use this? Tossing of a coin, sampling inspection, genetic experiments, and so on. Now, how do we fit a binomial distribution? Using method of moments method. By using method of moments, that is by calculating probability using this relationship, using that formula. Next one is Poisson distribution. So in case in all discrete probability distributions, we follow binomial. However, if binomial cannot be followed, if those conditions are not satisfied, we go with Poisson. If binomial cannot be followed, we go with Poisson. So in case of Poisson distribution, what happens? Probability is very small. Probability of finding success is very small. P is very small. And probability of having more than success is also very low. Probability of having success in this time interval is independent of T as well as earlier successes. So trials are independent. In such cases where P is very small, we go with Poisson distribution. How do we calculate Poisson distribution probability in case of Poisson distribution? E to the power of minus m, m to the power of x by x factorial, where m is the parameter of Poisson distribution. So m is the only parameter. Therefore, Poisson distribution is uniparametric. M is the only parameter. What is E? E is a constant. So 2.71828. The value of E is 2.71828. E to the power of minus m is always greater than 0. If summation f of x is 1, Poisson distribution is uniparametric. M. What is the mean in case of Poisson distribution?
M.
M. What is variance?
M.
M. So in case of Poisson distribution, mean is equal to variance. Standard deviation is root m. Mode similar to binomial distribution. Here also it depends on what is the value of m. If m is a non-integer, unimodal or bimodal? With binomial. Unimodal distribution. What is the mode? The largest integer included in m will be the mode. Whereas if m is an integer, then bimodal. What are the modes? M and
M minus 1.
M minus 1. Yes, M and M minus 1 are modes. Now, in some cases, binomial distribution can be approximated to Poisson when n tends to infinity and p tends to 0. We go with binomial distribution would be approximated to Poisson distribution. And if there are two distributions following Poisson, if we add those two distributions, the resultant distribution also follows Poisson distribution. X follows Poisson, Y follows Poisson, X plus Y, Z also follows Poisson distribution. Where do we apply this? This is applied when probability of occurrence is very small, like number of printing mistakes per page of a large book, number of road accidents of a busy road, number of radioactive elements per minute in a fusion process, number of demands per minute for health center, and so on. Again, fitting of Poisson distribution. How do we fit the Poisson distribution? Using that formula, e to the power of minus m, m to the power of x by x factorial, where m, how do we get m? M is the arithmetic mean. So for a given frequency distribution, we calculate m, the arithmetic mean, that m would be, arithmetic mean would be equated to m. Using that, we get e to the power of minus m, m to the power of x and x factorial. We'll calculate the corresponding probabilities and then fit a Poisson distribution to that frequency distribution. Similarly, binomial distribution also. Arithmetic mean is equal to n into p. We know m, so that we get p, probability of success. We get q, probability of failure. We can calculate ncx into p to the power of x into q to the power of n minus x. Then normal distribution or Gaussian distribution. The two distributions discussed so far, binomial and Poisson, are discrete. Continuous, we go with normal distribution. Normal, in case of normal distribution, what is the function? 1 divided by sigma root 2 pi into e to the power of minus x minus mu the whole square divided by 2 sigma square. Do we have to by heart this? The answer is 100% yes. We have to, by, because in certain cases they'll give questions in this format. We may have to find out what is mu, what is sigma square, etc. Obviously, we need not find out probabilities using this function. For that, we have a different calculation. We go with standard normal curve, right? Normal curve, normal distribution concept. But we may have to calculate mean and standard deviation using this. So we have to by heart that formula. What are the properties? Normal curve is bell-shaped. We have discussed this, right? It will have only one peak. So since it has only one peak, it is unimodal always, unlike binomial and Poisson. It is always unimodal distribution and it is symmetrical at mu, symmetrical at mean, symmetrical at mu. Binomial distribution is symmetrical at p is equal to 0.5. And these two tails will never touch the x-axis. It never touches. It will go till infinity. Hence, we have infinity and minus minus infinity and infinity. Right? Area between minus infinity and infinity is 0.5. Infinity and minus infinity is 0.5. Total area in the normal curve is 1. So if in this distribution, if we consider mu is equal to 0 and standard deviation is 1, then the resultant distribution that we get is standard normal distribution. The resultant distribution that we get is standard normal distribution. So normal distribution has two parameters. What are the two parameters? Mu and sigma square. So normal distribution is also biparametric. Binomial distribution, two parameters. What are the two parameters?
P and Q.
N and P. Poisson?
M.
Poisson? M. Normal distribution? Mean and variance. Mu and sigma square. Are the two parameters, mean and variance. Okay. What are the properties? Here, mean is equal to median is equal to mode. Mean is equal to median is equal to mode in case of normal distribution. Standard deviation is sigma. Mean deviation is 0.8 into sigma. These are very important properties. We have to remember. Quartile deviation is, quartiles. Q1 is mu minus 0.675 sigma. Q3 is mu plus 0.675 sigma. What is Q2?
Mu.
Because Q2 is median. Median is equal to mean. Right? So Q2 is mu. Quartile deviation, alternate quartile deviation is
0.675 sigma.
Yes, Q3 minus Q1 by 2, which is 0.675 sigma. Since normal distribution is symmetrical, skewness is 0, and there are 2 points of inflection. What are points of inflection? That is their curvature, convex to concave, concave to convex, they will change. The points of inflection are mu minus sigma, mu plus sigma. Mu minus sigma and mu plus sigma. So standard normal variation, when it will be a normal distribution, will be converted to standard normal distribution when its parameters are mu is
0 and sigma
variance
is
is
1.
Very good. Mu is 0 and variance is 1. And in a given curve, we can divide it into 1 sigma, 2 sigma, 3 sigma, that is minus 1 sigma, 2 sigma, and 3 sigma. So the total area between this is 99.73%. The total area between minus 3 sigma to plus 3 sigma is 99.73%. Next we have again, so to x follows normal, y follows normal, x plus y, z also follows normal distribution. Now, where do we use this normal distribution? We have various applications of normal distribution. We can go through the applications. Simple. Important is standard normal distribution. So in case of normal distribution, mean is mu, standard deviation is sigma. In case of standard normal distribution, mean is 0, standard deviation is 1. Correct? In case of normal distribution, what is mean deviation? What is mean deviation? We had just discussed. What is mean deviation?
0.8 sigma.
0.8 sigma. So in standard normal distribution, what would be the mean deviation? Sigma is 1, right? In standard normal distribution.
0.8.
So 0.8.
0.8.
Correct? 0.8. Quartile deviation in normal distribution is 0.675 sigma. So here quartile deviation would be
0.675.
0.675. Here it is symmetrical at mu. Here it is symmetrical at
0.
0 because mu is 0. Here 2 points of inflection are mu plus sigma, mu minus sigma. Here the points of inflection, mu is 0
and
plus
minus
1, 0 minus 1. So 1 and minus 1 are the points of inflection, right? And if x bar denotes arithmetic mean of random sample of size n drawn from a normal population, then z, the standard normal variate, is root n of x bar minus mu by sigma. Not so important. However, go through that formula in case if it is asked. Obviously, practical question cannot be asked there. Okay, these are the different types of theoretical distributions. So what are the theoretical distributions that we have discussed? Binomial distribution, their properties and the formula is important. Poisson distribution, properties and formula. Normal distribution, two types: normal distribution and standard normal distribution. Normal distribution, we have mu and sigma. Standard normal distribution, 0 and 1 are the parameters. Clear? Yes, again, properties are important in that, and the formulas are important where we may have to calculate the respective probabilities. That's all. That is there in theoretical distribution. So we'll quickly look into some of the questions of theoretical distribution. Okay. What is the probability of getting 3 heads if 6 unbiased coins are tossed simultaneously? Which distribution?
Binomial distribution.
Tossing of a coin, binomial distribution. So first consider the parameters. What is n?
N is 6.
6. What is p?
0.5.
Yes, tossing of a coin, 0.5. Q also will be 0.5. So here what we'll require, x is equal to
3.
3 heads. 3. So 6c3, 1 by 2 to the power of 3, 1 by 2 to the power of 6 minus 3, which is again 3. So 6c3 is 20. 1 by 2 to the power of 3 is 0.125 into 0.125, 0.3125. This is the answer. Then mode of the binomial distribution we have to calculate. Mean is 4, variance is 3. Mean is, what is mean? Binomial distribution?
NP.
NP is 4. What is variance?
NPQ.
Yeah, NPQ. NPQ is 3. NP is 4, NPQ is 3. So how do we calculate mode? For that, we'll require n plus 1 into p, correct? Right?
Yes, sir.
So we want n and p. So using this, can I calculate n and p?
Yes, sir.
Yes, NP is 4. So here, instead of NP, I'll write 4. So 4Q is 3. So what is Q?
3 by 4.
If Q is 3 by 4, what is P?
1 by 4.
1 by 4. So in NP, if I know P is 1 by 4, what would be N?
16.
1 by 4, if I send the other side, it will be 4. So 4 into 4, 16. So N is 16, P is 1 by 4. N plus 1 into P, 16 plus 1 into 1 by 4. We get?
17 by 4.
17 by 4.
4.25.
Obviously, it is 4.25. Yeah, obviously, it is non-integer. In case of non-integers, unimodal or bimodal?
Unimodal.
Unimodal. What is the mode?
4.
4. Highest integer. 4. 4 is the mode. For Poisson distribution, mean and standard deviation are equal. Mean and variance are equal. What are equal?
Mean and variance are equal.
Variance are equal.
Yes, mean and variance are equal. M. Mean is M. Variance is also M, not standard deviation. Variance. If a variate X has mean greater than variance, then the distribution is
Binomial.
Binomial distribution, mean is greater than variance. Example of biparametric continuous probability distribution.
Normal.
Yes, it is continuous probability distribution, so it has to be normal. If it was just biparametric, then it could be binomial or normal, because binomial is also two parameters. For Poisson variate X, P of X is equal to 2 is equal to 3 into P of X is equal to 4, then standard deviation of X is, this is Poisson variation, Poisson distribution, e to the power of minus m to the power of x factorial, correct? X is equal to 2, e to the power of minus m. What is m to the power of x is 2 divided by 2 factorial is equal to 3 into e to the power of minus m to the power of 4 by 4 factorial.
By 24.
5 more minutes, we'll be closing. Okay, concentrate. So e to the power of minus m, e to the power of minus m gone. M square remains. 2 factorial, what will remain here? 4 into 3,
12.
2 into 1. 2 into 1 goes. 2 factorial is 2 into 1, 2 into 1 goes. So 4 into 3 remains. So here 1 is equal to 3m square divided by
12. M
So 3
square
ones are 3 fours are. So m square is 4. So what is m?
plus or minus 2.
2. So we require standard deviation. What would be standard deviation?
Root 2.
Root 2, not 4.
Root 2.
See, variance is 2. So standard deviation should be root 2. Correct? Standard deviation is root 2. Now, this is what I was talking about. What is the mean of x having the following density function? This is normal distribution format. We want mean. What
4.
is mean? Mu.
4.
4? No. 1 minus sigma root 2 pi. This is standard deviation, not mean. E to the power of minus x minus mu the whole square.
10.
This is mu. So 10 is arithmetic mean. Arithmetic mean is 10. If they had asked standard deviation, yes, 4 is the standard deviation. Correct. Okay. Then that's all. Okay, fine. So these are the questions in theoretical distribution. Okay, anyone has any doubts in this? Obviously at 9:30, no one will have any doubt. Fine. Read, okay, read these concepts that we have discussed. Start with the first chapter itself. In the next class, we will finish the statistics, go with logical reasoning, and then start with mathematics.
Okay, sir.
Yes.
Yes, sir.
Harshita, can you ask that question? I'm not understanding your chat.
Sir, I didn't put any question.
Not you, Harshita Joshi. When we get answer in point, for example, we get answer as 44.4 and there is 44 and none of these as options. Okay, I understood. So we are getting 44.4 as the answer. And in the options, we have 44 and none of these as the options. So in such case, what is the answer to tick? So that depends on the options that we have. Okay. So if the options are 44, 44.1, 44.2, 44.3, and none of this, then better to go with none of this. If the options are 44, 88, 122, 144, then go with 44.
And sir, in account, average due date calculation,
Accounts, okay.
So there, generally when we get the answer like 123.3 days or something, so in the material they round it off to 124 days, but shouldn't we round it off to 123 days actually?
See, what happens is average due date. What is the concept? The date on which no interest loss. So that cannot be a previous date. See, when you say 30th of May is the average due date, and we are getting 123, okay, 123.3 days is the average due date that we are getting. So if we apply 123.3, that we are getting 30th of May, mid 30th of May. So I cannot prepone the payment of interest. You have to always give the next day as the average due date. Okay. Because this is payment of interest related. So
anything we get, we should take it to the next day itself. 123.1, 2, 3, 4, anywhere.
Yes, correct.
Okay, sir. Okay, thank you.
Should be the next date. Okay, fine. Thank you. We'll meet tomorrow.
Yes, sir.
Yes,
Thank
sir.
you.
Thank you,
Others
sir.
don't leave. Wait, others don't leave. I have an announcement to make. Thank you so much, sir.
Bye, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir. This was so sweet. Asked a little quick. Okay. Yeah. So on Wednesday, Wednesday, that is on end date, 1st of June. See, we are already entering June now. Awesome. So 1st of June, Wednesday, there is a meeting about Science Park. The Science Park iruttala. Science Park meeting ide. Everybody must and should join. ಅದ್ರಲ್ಲಿ ಏನ್ ಓದ್ಸೋದು ಯಾರು ಏನ್ ನಿಮಗೆ ಓದ್ಸಲ್ಲ ಜಾಸ್ತಿ, ಏನ್ ಬರೆಯಕ್ಕೆ ಏನಿರಲ್ಲ, ಎಲ್ಲಾರು ಬರ್ಬೇಕು. ಅರ್ಥ ಆಯ್ತಲ್ಲ? Everybody must come. It's a must and should meeting. And if you don't come, probably, I don't know, ಇವತ್ತಿಂದು recording YouTube is public because number was there. But if you don't come to the meeting on Wednesday, none of the other R2C session recordings will be uploaded publicly. Is everybody clear with that?
Yes.
Okay.
Yes.
Okay, guys, it's 9:36 p.m. right now. Please go home from
Okay.
your room to your kitchen. In your case, Pradyumna, food will only come to your bedroom, I presume. You don't have to go anywhere.
Don't presume such things. Okay, I'll only go.
Oh, wow. Ashton distance
ಹೌದು,
ಓಡಾಡ್ತೀನೋ Pradyumna?
ಹೌದು.
Okay. Go and have dinner in case you have not had. I mean, you shouldn't have had. So go and have and meet you guys tomorrow at the same time, but 6:30. Alva?
Yes.
30. We'll meet you at 6:30 tomorrow.
Okay.
And you guys can all leave. Anybody has anything to ask, say, can stay back.
Okay, bye.
Bye.
ಜೂನ್ ಫಸ್ಟ್ ಎಷ್ಟು ಹೊತ್ತಿಗೆ?
ಗೊತ್ತಿಲ್ಲ ಈವ್ನಿಂಗ್. ಹೆಂಗಿದ್ಯಾ ನೀನು? ಹುಷಾರಾಗಿದ್ಯಾ? ಫೈನಾ?
ನೀನು?
ಓಕೆ. ಅಲ್ಲ ನಿನಗೇನೋ ಜ್ವರ ಬಂದಿತ್ತಲ್ಲ ಅದಕ್ಕೆ ಕೇಳಿದ್ ನಾನು.
ಶೀತ